Chưa bật mic à? Thì là cũng chả quan tâm đâu. Ok. Rồi, với AI ha, như tiêu đề. Giờ là một ván câu khởi động. Trận thua nhục nhã. AI Discord. Trên cao vậy. That's why we need chiều sóc mắt. Mắt là gì đấy nhá? Okay. That's
and Z2 and so on to get A1 and A2 and A3 and A4. But with the softmax activation function, notice that A1 is a function of Z1 and Z2 and Z3 all the way up to Z10. So each of these activation values depends on all of the values of Z. And this is a property that's a bit unique to the softmax output of the softmax activation function. Or stated differently, if you want to compute A1 through A10, that is a function of Z1 all the way up to Z10 simultaneously. And this is unlike the other activation functions we've seen so far. Finally, let's look at how you would implement this in TensorFlow. If you want to implement the neural network that I've shown here on this slide, this is the code to do so. Similar as before, there are 3 steps to specifying and training a model. The first step is to tell TensorFlow to sequentially string together 3 layers. First layer is this 25 units with ReLU activation function. Second layer, 15 units with ReLU activation function. And then the third layer, because there are now 10 output units, you want to output A1 through A10, so there are now 10 output units, and we'll tell TensorFlow to use the softmax activation function. And the cost function that you saw in the last video, TensorFlow calls that the sparse categorical cross-entropy function. So I know this name is a bit of a mouthful. Whereas for logistic regression, we had the binary cross-entropy function. Here, we're using the sparse categorical cross-entropy function. And what sparse categorical refers to is that you're still classifying Y into categories. So it's categorical. It takes on values from 1 to 10. And sparse refers to that Y can only take on one of these 10 values. So each image is either 0 or 1 or 2 or so on up to 9. You're not going to see a picture that is simultaneously the number 2 and the number 7. So sparse refers to that. Each digit is only one of these categories. So that's why the loss function that you saw in the last video is called in TensorFlow the sparse categorical cross entropy loss function. And then the code for training the model is just the same as before. And if you use this code, you can train a neural network on a multi-class classification problem. Just one important note, if you use this code exactly as I've written here, it will work, but don't actually use this code because it turns out that in TensorFlow, there's a better version of the code that makes TensorFlow work better. So even though the code shown in this slide works, don't use this code the way I've written it here, because in a later video this week, you see a different version. There's actually the recommended version of implementing this that will work better. But we'll take a look at that in a later video. So now you know how to train a neural network with a softmax output layer with one caveat. There's a different version of the code with one caveat. There's a different version of the code that will make TensorFlow able to compute these probabilities much more accurately. Let's take a look at that in the next video, which will also show you the actual code that I recommend you use if you're training a softmax neural network. Let's go on to the next video. The implementation that you saw in the last video of a neural network with a softmax layer will work okay, but there's an even better way to implement it. Let's take a look at what can go wrong with that implementation and also how to make it better. Let me show you two different ways of computing the same quantity in a computer. Option 1, we can set x equals to 2 over 10,000. Option 2, we can set x equals 1 plus 1 over 10,000 minus 1 minus 1 over 10,000, in which you first compute this, and then compute this, and you take the difference. And if you simplify this expression, this turns out to be equal to 2 over 10,000. Let me illustrate this in this notebook. So first, let's set x equals 2 over 10,000 and print the result to a lot of decimal points of accuracy. Okay, that looks pretty good. Second, let me set x equals, I'm going to insist on computing 1 over 1 plus 10,000, and then subtract from that 1 minus 1 over 10,000, and let's print that out. And, oh, okay, this looks a little bit off. As if there's some round off error. Because a computer has only a finite amount of memory to store each number, called a floating point number in this case, depending on how you decide to compute the value 2 over 10,000, the result can have more or less numerical round-off error. And it turns out that while the way we have been computing the cost function for softmax is correct, there's a different way of formulating it that reduces these numerical round-off errors, leading to more accurate computations within TensorFlow. Let me first explain this in a little bit more detail using logistic regression, and then we will show how these ideas apply to improving our implementation of softmax. So first, let me illustrate these ideas using logistic regression, and then we'll move on to show how to improve your implementation of softmax as well. Recall that for logistic regression, if you want to compute the loss function, for a given example, you would first compute this output activation A, which is g of z, or 1 over 1 plus e to the negative z, and then you compute the loss using this expression over here. And in fact, this is what the code would look like for a logistic output layer with this binary cross-entropy loss. And for logistic regression, this works okay, and usually the numerical round-off errors aren't that bad. But it turns out that if you allow TensorFlow to not have to compute A as an intermediate term, but instead, if you tell TensorFlow that the loss is this expression down here, and all I've done is I've taken A and expanded it into this expression down here, then TensorFlow can rearrange terms in this expression and come up with a more numerically accurate way to compute this loss function. And so whereas the original procedure was like insisting on computing as an intermediate value 1 plus 1 over 10,000 and another intermediate value 1 minus 1 over 10,000 and then manipulating these two to get 2 over 10,000, this original implementation was insisting on explicitly computing A as an intermediate quantity. But instead, by specifying this expression at the bottom directly as a loss function, it gives TensorFlow more flexibility in terms of how to compute this and whether or not it wants to compute A explicitly. And so the code you can use to do this is shown here. And what this does is it sets the output layer to just use a linear activation function, and it puts both the activation function, 1 over 1 plus e to the negative z, as well as this cross-entropy loss into the specification of the loss function over here. And that's what this from logits equals true argument causes TensorFlow to do. And in case you're wondering what the logits are, is basically this number z. So TensorFlow will compute z as an intermediate value, but it can rearrange terms to make this become computed more accurately. One downside of this code is it becomes a little bit less legible, but this causes TensorFlow to have a little bit less numerical round-off error. Now, in the case of logistic regression, either of these implementations actually works okay, but the numerical round-off errors can get worse when it comes to softmax. Now, let's take this idea and apply it to softmax regression. Recall what you saw in the last video was you compute the activations as follows. The activations is g of z1 through z10, where a1, for example, is e to the z1 divided by the sum of the e to the zj's. And then the loss was this, depending on what is the actual value of y, is negative log of aj for one of the aj's. And so this was the code that we had to do this computation in 2 separate steps. But once again, if you instead specify that the loss is, if y is equal to 1, is negative log of this formula, and so on. If y is equal to 10, is this formula, then this gives TensorFlow the ability to rearrange terms and compute this in a more numerically accurate way. Just to give you some intuition for why TensorFlow might want to do this, it turns out if one of the z's is really small, then e to the negative small number becomes very, very small. Or if one of the z's is a very large number, then e to the z can become a very, very large number. And by rearranging terms, TensorFlow can avoid some of these very small or very large numbers, and therefore come up with a more accurate computation for the loss function. So the code for doing this is shown here. In the output layer, we're now just using a linear activation function. So the output layer just computes z1 through z10, and this whole computation of the loss is then captured in the loss function over here, where again, we have the from logits equals true parameter. So once again, these two pieces of code do pretty much the same thing, except that the version that is recommended is more numerically accurate, although unfortunately it is a little bit harder to read as well. So if you're reading someone else's code and you see this and you wonder what's going on, it's actually equivalent to the original implementation, at least in concept, except that it's more numerically accurate. The numerical round-off errors for logistic regression aren't that bad, but it is recommended that you use this implementation down at the bottom instead. And conceptually, this code does the same thing as the first version that you had previously, except that it is a little bit more numerically accurate. Although the downside is maybe just a little bit harder to interpret as well. Now, there's just one more detail, which is that we've now changed the neural network to use a linear activation function rather than a softmax activation function. And so the neural network's final layer no longer outputs these probabilities A1 through A10. It is instead outputting Z1 through Z10. And I didn't talk about it in the case of logistic regression, but if you were combining the output logistic function with the loss function, then for logistic regression, you also have to change the code this way to take the output value and map it through the logistic function in order to actually get the probability. So you now know how to do multi-class classification with a softmax output layer, map it through the logistic function.
Ok. Nhưng chắc chắn quan trọng đâu.
Function in order to actually get the probability. So you now know how to do multi-class classification with a softmax output layer, and also how to do it in a numerically stable way. Before wrapping up multi-class classification, I want to share with you one other type of classification problem called a multi-label classification problem. Let's talk about that in the next video. You've learned about multi-class classification, where the output label y can be any one of two or potentially many more than two possible categories. There's a different type of classification problem called a multi-label classification problem, which is where, associated with each image, there could be multiple labels. Let me show you what I mean by that. If you're building a self-driving car or maybe a driver assistance system, then given a picture of what's in front of your car, you may want to ask a question like, is there a car, or at least one car? Or is there a bus? Or is there a pedestrian? Or are there any pedestrians? So in this case, there is a car, there is no bus, and there is at least one pedestrian. Or in this second image, no cars, no buses, and yes to pedestrians, and yes car, yes bus, and no pedestrians. So these are examples of multi-label classification problems because associated with a single input image X are three different labels corresponding to whether or not there are any cars, buses, or pedestrians in the image. So in this case, the target output Y is actually a vector of three numbers. And this is as distinct from multi-class classification, where for, say, handwritten digit classification, Y was just a single number, even if that number could take on 10 different possible values. So how do you build a neural network for multi-label classification? One way to go about it is to just treat this as three completely separate machine learning problems. You could build one neural network to decide are there any cars, a second one to detect buses, and the third one to detect pedestrians. And that's actually not an unreasonable approach. Here's the first neural network to detect cars, second one to detect buses, third one to detect pedestrians. But there's another way to do this, which is to train a single neural network to simultaneously detect all three of cars, buses, and pedestrians, which is if your neural network architecture looks like this. There's your input X, first hidden layer outputs A1, second hidden layer outputs A2, and then the final output layer, in this case, would have three output neurons and will output A3, which is going to be a vector of three numbers. And because we're solving three binary classification problems, so is there a car, is there a bus, is there a pedestrian, you can use a sigmoid activation function for each of these three nodes in the output layer. And so A3 in this case will be A31, A32, and A33, corresponding to whether or not the learning algorithm thinks there's a car, and or a bus, and or pedestrians in the image. So multi-class classification and multi-label classification are sometimes confused with each other. And that's why in this video, I want to share with you just a definition of multi-label classification problems as well, so that depending on your application, you could choose the right one for the job you want to do. So that's it for multi-label classification. I find that sometimes multi-class classification and multi-label classification are confused with each other, which is why I wanted to explicitly, in this video, share with you what is multi-label classification, so that depending on your application, you can choose the right tool for the job that you want to do. And that wraps up the section on multi-class and multi-label classification. In the next video, we'll start to look at some more advanced neural network concepts, including an optimization algorithm that is even better than gradient descent. So let's take a look at that algorithm in the next. Next video, because it'll help you to get your learning algorithms to learn much faster. So let's go on to the next video.
Vâng, 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 vâng. Thật là mệt mỏi. Trò chơi kích thích thì tớ lại không đang gọi rồi. Ngủ chưa, kích thích thì cho thôi. Giả sử dậy 8 giờ sáng, việc cháy sườn mới ấy chứ. Ai, có như kiến thức tốt thật. Chắc là do Xuân chưa rồi. Em có đi ăn. Ôi, ừ. Tôi ừ. Nó nhảy ở đây mà. Tôi để ở đây hay sao không? Rồi, học hành 10 tiếng. Hay làm quả stream chơi game nhỉ? Học cái cho nó tinh thần. Ờ, gọi lại ác rồi. Thật khó thiệt. Notice that in the ref murder output not probability but number number to a soft mass when performing prediction that probability output. Uh, smart. Okay. The output prediction of probability if this output probability, the output should be processed by a soft mass. Chứ không có phải lắm nhỉ. Cho example. Cái trên là cái dưới là cái dưới là predict nhưng mà soft mass đúng không? Một soft mass hả? Nghe rồi. Giờ mới không đến một đúng không? For E right now. Or map prefer. Kể từ 2 năm trung bình gần đâu nhất hả? Kiểu vậy. Ôi ôi. Ôi 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 ôi. Cái tóc tai. Ok, thế là
Gradient descent is an optimization algorithm that is widely used in machine learning and was the foundation of many algorithms like linear regression and logistic regression and early implementations of neural networks. But it turns out that there are now some other optimization algorithms for minimizing the cost function that are even better than gradient descent. In this video, we'll take a look at an algorithm that can help you train your neural network much faster than gradient descent. Recall that this is the expression for one step of gradient descent. A parameter wj is updated as wj minus the learning rate alpha times this partial derivative term. How can we make this work even better? In this example, I plotted the cost function j using a contour plot comprising these ellipses, and so the minimum of this cost function is at the center of these ellipses down here. Now, if you were to start gradient descent down here, one step of gradient descent, if alpha is small, may take you a little bit in that direction, then another step, then another step, then another step, then another step. And you notice that every single step of gradient descent is pretty much going in the same direction. And if you see this to be the case, you might wonder, well, why don't we make alpha bigger? Can we have an algorithm to automatically increase alpha to just make it take bigger steps and get to the minimum faster? There's an algorithm called the Adam algorithm that can do that. If it sees that the learning rate is too small and we are just taking tiny little steps in a similar direction over and over, we should just make the learning rate alpha bigger. In contrast, here again is the same cost function. If we were starting here and had a relatively big learning rate alpha, then maybe one step of gradient descent takes us here, and the second step takes us here, third step, and the fourth step, and the fifth step, and the sixth step. And if you see gradient descent doing this, it's oscillating back and forth, you'd be tempted to say, well, why don't we make the learning rate smaller? And the Adam algorithm can also do that automatically. And with a smaller learning rate, you can then take a more smooth path toward the minimum of the cost function. So depending on how gradient descent is proceeding, sometimes you wish you had a bigger learning rate alpha, and sometimes you wish you had a smaller learning rate alpha. So the Adam algorithm can adjust the learning rate automatically. Adam stands for adaptive moment estimation. Or ADAM. And don't worry too much about what this name means. It's just what the authors had called this algorithm. But interestingly, the Adam algorithm doesn't use a single global learning rate alpha. It uses a different learning rate for every single parameter of your model. So if you have parameters W1 through W10 as well as B, then it actually has 11 learning rate parameters, alpha 1, alpha 2, all the way through alpha 10 for W1 through W10, as well as I'll call it alpha 11 for the parameter B. And the intuition behind the Adam algorithm is if a parameter, Wj or B, seems to keep on moving in roughly the same direction. This is what we saw on the first example on the previous slide. But if it seems to keep on moving in roughly the same direction, let's increase the learning rate for that parameter. Let's go faster in that direction. Conversely, if a parameter keeps oscillating back and forth, this is what you saw in the second example on the previous slide, then let's not have it keep on oscillating or bouncing back and forth. Let's reduce alpha j for that parameter a little bit. The details of how Adam does this are a bit complicated and beyond the scope of this course, but if you take some more advanced deep learning classes later, you may learn more about the details of this Adam algorithm. But in code, this is how you would implement it. The model is exactly the same as before, and the way you compile the model is very similar to what we had before, except that we now add one extra argument to the compile function, which is that we specify that the optimizer you want to use is tf.keras.optimizers.the Adam optimizer. So the Adam optimization algorithm does need some default initial learning rate alpha. And in this example, I've set that initial learning rate to be 10 to the negative 3. But when you're using the Adam algorithm in practice, it's worth trying a few values for this default global learning rate. Try some larger and some smaller values to see what gives you the fastest learning performance. Compared to the original gradient descent algorithm that you had learned in the previous course, though, the Adam algorithm, because it can adapt the learning rate a bit automatically, it is more robust to the exact choice of learning rate that you pick. Though it is still worth tuning this parameter a little bit to see if you can get somewhat faster learning. So that's it for the Adam optimization algorithm, somewhat faster learning.
Cố gắng lại ở đây. Đỡ nhé. Ngoài trời phết. Cửa hơi yếu phần gì. Ok. Được. Rồi. Ngủ điên.
Learning. So that's it for the Adam optimization algorithm. It typically works much faster than gradient descent and it's become a de facto standard in how practitioners train their neural networks. So if you're trying to decide what learning algorithm to use, what optimization algorithm to use to train your neural network, a safe choice would be to just use the Adam optimization algorithm. And most practitioners today will use Adam rather than the original gradient descent algorithm. And with this, I hope that your learning algorithms will be able to learn much more quickly. Now, in the next couple videos, I'd like to touch on some more advanced concepts for neural networks. And in particular, in the next video, let's take a look at some alternative layer types. All the neural network layers we've used so far have been the dense layer type, in which every neuron in a layer gets as its inputs all the activations from the previous layer. And it turns out that just using the dense layer type, you can actually build some pretty powerful learning algorithms. And to help you build further intuition about what neural networks can do, it turns out that there's some other types of layers as well with other properties. In this video, I'd like to briefly touch on this and give you an example of a different type of neural network layer. Let's take a look. To recap, in the dense layer that we've been using, the activation of a neuron in, say, the second hidden layer is a function of every single activation value from the previous layer of A1. But it turns out that for some applications, someone designing a neural network may choose to use a different type of layer. One other layer type that you may see in some work is called a convolutional layer. Let me illustrate this with an example. So what I'm showing on the left is the input X, which is a handwritten digit 9. And what I'm going to do is construct a hidden layer which will compute different activations as functions of this input image X. But here's something I can do. For the first hidden unit, which I've drawn in blue, rather than saying this neuron can look at all the pixels in this image, I might say this neuron can only look at the pixels in this little rectangular region. Second neuron, which I'm going to illustrate in magenta, is also not going to look at the entire input image X. Instead, is only going to look at the pixels in a limited region of the image. And so on for the third neuron and the fourth neuron, and so on and so forth, down to the last neuron, which maybe looks only at that region of the image. So why might you want to do this? Why won't you let every neuron look at all the pixels, but instead look at only some of the pixels? Well, some of the benefits are, first, it speeds up computation.
Yeah.
And second advantage is that a neural network that uses this type of layer, called a convolutional layer, can need less training data. Or alternatively, it can also be less prone to overfitting. You'd heard me talk a bit about overfitting in the previous course, but this is something that we'll dive into greater detail on next week as well, when we talk about practical tips for using learning algorithms. And this particular type of layer, where each neuron only looks at a region of the input image, is called a convolutional layer. It was a researcher, Jan Kuhn, who had figured out a lot of the details of how to get convolutional layers to work and popularize their use. Let me illustrate in more detail a convolutional layer. And if you have multiple convolutional layers in a neural network, sometimes that's called a convolutional neural network. To illustrate the convolutional layer or convolutional neural network, on this slide, I'm going to use, instead of a 2D image input, I'm going to use a one-dimensional input. And the motivating example I'm going to use is classification of EKG signals or electrocardiograms. So if you put two electrodes on your chest, you will record voltages that look like this that correspond to your heartbeat. This is actually something that my Stanford research group did research on. We're actually reading EKG signals that actually look like this to try to diagnose if a patient may have a heart issue. So an EKG signal, an electrocardiogram, ECG in some places, EKG in some places, is just a list of numbers corresponding to the height of this surface at different points in time. So you may have, say, 100 numbers corresponding to the height of this curve at 100 different points of time. And the learning task is, given this time series, given this EKG signal, to classify, say, whether this patient has a heart disease. or some diagnosable heart condition. Here's what a convolutional neural network might do. So I'm going to take the EKG signal and rotate it 90 degrees to lay it on the side. And so we have here 100 inputs, x1, x2, all the way through x100, like so. And when I construct the first hidden layer, instead of having the first hidden unit take as input all 100 numbers, let me have the first hidden unit look at only x1 through x20. So that corresponds to looking at just a small window of this EKG signal. The second hidden unit, shown in a different color here, will look at x11 through x30. So it looks at a different window in this EKG signal. And the third hidden layer looks at another window, x21 through x40, and so on. And the final hidden unit in this example will look at x81 through x100, so it looks at a small window toward the end of this EKG time series. So this is a convolutional layer because each unit in this layer looks at only a limited window of the input. Now, this layer of the neural network has 9 units. The next layer can also be a convolutional layer. So in the second hidden layer, let me architect my first unit not to look at all 9 activations from the previous layer, but to look at, say, just the first 5 activations from the previous layer. And then my second unit is activated regarding a single neuron should look at networks. To recap, that's it for the convolutional layer and convolutional neural networks. I'm not going to go deeper into convolutional networks in this class, and you don't need to know anything about them to do the homeworks and finish this class successfully. But I hope that you find this additional intuition that neural networks can have other types of layers as well to be useful. And in fact, if you sometimes hear about the latest cutting-edge architectures, like a transformer model or an LSTM or an attention model, a lot of this research in neural networks, even today, pertains to researchers trying to invent new types of layers for neural networks and plugging these different types of layers together as building blocks to form even more complex and hopefully more powerful neural networks. So that's it for the required videos for this week. Thank you and congrats on sticking with me all the way through this. And I look forward to seeing you next week also, where we'll start to talk about practical advice for how you can build machine learning systems. I hope that the tips you learn next week will help you become much more effective at building useful machine learning systems. So I look forward also to seeing you next week. You've seen how in TensorFlow you can specify a neural network architecture, so compute the output y as a function of the input x, and also specify a cost function, and TensorFlow will then automatically use backpropagation to compute derivatives and use gradient descent or Adam to train the parameters of your neural network. So the backpropagation algorithm, which computes derivatives of your cost function with respect to the parameters, is a key algorithm in neural network learning. But how does it actually work? In this and in the next few optional videos, we'll try to take a look at how backpropagation computes derivatives. These videos are completely optional, and they do go just a little bit into calculus. If you're already familiar with calculus, I hope you enjoy these videos, but if not, it's totally fine. We'll build up from the very basics of calculus to try to make sure you have all the intuition you need to understand how backpropagation works. Let's take a look. I'm going to use a simplified cost function, j of w equals w squared. So the cost function is a function of the parameters w and say b. And for the simplified cost function, let's just pretend j of w equals w squared. And I'm going to ignore b for this example. And let's say the value of the parameter w is equal to 3. So j of w will be equal to 9, w squared, or 3 squared. Now, if we were to increase w by a tiny amount, say epsilon, which I'm going to set to 0.001, how the simplified abbreviated form? The computation drives neural network with one output unit. Given it takes as inputs x, applies a linear activation function, and outputs the activation a. More specifically, its output is a equals wx plus b. So it's basically linear regression, but expressed as a neural network with one output unit. Given the output, the cost function is then 1/2 a, that is the predicted value, minus the actual observed value y squared. And for this small example, we're only going to have a single training example. where the training example is the input x equals -2, the ground truth output value y equals 2, and the parameters of this network are w equals 2 and b equals 8. So what I'd like to do is show how the computation of the cost function j can be computed step by step using a computation graph. And just as a reminder, when learning, we like to view the cost function j as a function of the parameters w and b. Let's take the computation of j and break it down into individual steps. First, you have the parameter w, that is an input to the cost function j, and then we first need to compute w times x, and let me just call that c as follows. W is equal to 2, x is equal to -2, and so c would be -4. And I'm just going to write the value here on top of this line, on top of this arrow, to show the value that is your output on this arrow. The next step is then to compute a, which is wx plus b. So let me create another node here, and this needs to input b, the other parameter that is input to the cost function j, and a equals wx plus b, so it's equal to c plus b, and if you add these up, that turns out to be 4. And so this is starting to build up a computation graph in which the steps we need to compute the cost function j are broken down into smaller steps. The next step is to then compute a minus y, which I'm going to call d. So let me have that node d, which computes a minus y. Y is equal to 2, so 4 minus 2 is 2. And then finally, j is the cost, is 1/2 of a minus y squared, or 1/2 of d squared, which is just equal to 2. What we've just done is build up a computation graph. And this is a graph, not in the sense of plots with x and y axes, but this is the other sense of the word graph used in computer science, which is that this is a set of nodes that is connected by edges, or connected by arrows in this case. So this computation graph shows the forward prop step of how we compute the output A of the neural network, but then also go further than that to also compute the value of the cost function j. The question now is, how do we find the derivative of j with respect to the parameters w and b? Let's take a look at that next. So here's the computation graph from the previous slide, and we've completed forward prop, where we've computed that j, the cost function, is equal to 2 through all these steps going from left to right, forward prop in the computation graph. What we'd like to do now is compute the derivative of j with respect to w and the derivative of j with respect to b. And it turns out that whereas forward prop was a left to right calculation, computing the derivatives will be a right to left calculation, which is why it's called back prop, or it's going backwards from right to left. The final computation node of this graph is this one over here, which computes j equals 1/2 of d squared. The first step of backprop is well, we know that really relying on the chain rule for calculus times then is to keep, and we know if j with respect to, if w were to go with it with respect to b x 2.02, and so roughly j has gone from 2 down to 1.996, and then an extra 0.02, and j has therefore gone down by 4 times epsilon. So to do this, we calculate c, a, and d here in how deep learning algorithms are implemented today in P steps. And if you have a neural network with, say, 10,000 nodes and maybe 100,000 parameters, this would not be considered even a very large neural network by modern standards. Being able to compute the derivatives in 10,000 plus 100,000 steps, which is 110,000, is much, much better than needing 10,000 times 100,000 steps, which would be 1 billion steps. And so the backpropagation algorithm done using the computation graph gives you a very efficient way to compute all the derivatives. And that's why it is such a key idea in how deep learning algorithms are implemented today. In this video, you saw how the computation graph takes all the steps of the calculation needed to compute the output of a neural network A, as well as the cost function J, and takes the... In this final video on intuition for backprop, let's take a look at how the computation graph works on a larger neural network example. Here's the network we will use with a single hidden layer, with a single hidden unit that outputs A1, that feeds into the output layer that outputs the final prediction A2. To make the math more tractable, I'm going to continue to use just a single training example with inputs X.
Đó là lấy cửa. Ôi, tôi lỡ cái quả tiêu đề chảy trâu quá rồi. Trời ơi, 10 tiếng đau đầu vai. Rồi, cái nó không khó mà nó cứ bất nào. Nó không ứng dụng ấy, xem hơi chán. Mà để cố đọc đọc để hiểu hiểu hơi mệt. Nó không khó đến mức đấy. Hơi mệt. À,
X equals 1, y equals 5, and these will be the parameters of the network. And throughout, we're going to use the ReLU activation function, so g of z equals max of 0, comma z. So for a prop in the neural network looks like this. As usual, a1 equals g of w1 times x plus b1. And so it turns out w1x plus b will be positive. So we're in the max 0 z equals z parts of this activation function. So that's just equal to this, which is 2 times 1. That's w1 is 2 times x is 1 plus 0.
Nhà lab cũng có cái mẹ gì đâu. Chỉ có mấy cái lệnh. Xong rồi bấm vào rồi nó chạy. Rồi mình đứng mình vỗ tay. Mà câu hỏi thì dễ. Xem phương xem hoa rồi của ích thì chả khó như thế, chẳng qua nó hơi hơi khô. Từ chắc là sắp ứng dụng rồi. Vậy.
That's b1, which is equal to 2. And then similarly, a2 equals this, g of w2, a1 plus b2, which is w2 times a1 plus b, again, because we're in the positive part of the ReLU activation function, which is 3 times 2 plus 1, which is equal to 7. Finally, we'll use the squared error cost function. So j of wb is 1 half a2 minus y squared, which is 1 half 7 minus 5 squared, which is 1 half of 2 squared, which is just equal to 2. Computes z. Finally, 2. And write calculations here to be 2. So to be 2 for the, and therefore j will equal to 2. Also equal to, so that's backprop. And again, I didn't go through the mechanical steps of every single step of backprop, but it's basically the process that you saw in the previous video. Let me just double check one of these examples. So we saw here that the derivative of j with respect to w1 is equal to 6. So what this is predicting is that if w1 goes up by epsilon, j should go up by roughly 6 times epsilon. Let's step through the math and see if that really is true. These are the calculations that we did again. And so if w, which was 2, were to be 2.001, goes up by epsilon, then a1 becomes, let's see, instead of 2, this is 2.001 as well. So a1 instead of 2 is now 2.001. So 3 times 2.001 plus 1, this gives us 7.003. And if a2 is 7.003, then this becomes 7.03 minus 5 squared. And so this becomes 2.003 squared over 2, which turns out to be equal to 2.00605. So ignoring some of the extra digits, you see from this little calculation that if w1 goes up by 0.001, j of w has gone up from 2 to 2.006 roughly. So 6 times as much. And so the derivative of j with respect to w1 is indeed equal to 6. And so the backprop procedure gives you a very efficient way to compute all of these derivatives, which you can then feed into the gradient descent algorithm or the Adam optimization algorithm to then train the parameters of your neural network. And again, the reason we use backprop for this is a very efficient way to compute all the derivatives of j with respect to w1, j with respect to b1, j with respect to w2, and j with respect to b2. I did just illustrate how we could bump up w1 by a little bit and see how much j.
Đây là mấy cái bắt đầu hơi hơi khó một chút là cả cái này chả có cái gì là cần thiết mấy cả. Cho biết thôi, ví dụ thì không cần gì là nhờ biết ngay. Ý là mấy cái mà cần biết nhưng mà nó hơi hơi khó một chút như là cái này nó chả khó lúc đấy thì nó bắt đầu mở ngoặc optional rồi, kiểu dạy cho trẻ con học ấy. Trời ơi, nó còn giảm derivative là gì. Tôi thiếu một tí thôi thành chuyên gia rồi.
j changes, but that was a left to right calculation. And if we had to do this procedure for each parameter, one parameter at a time, if we had to increase w by 0.01 to see how that changes.
Kiểu nó hơi công thức gì thôi, không nói nó thành optional rồi. Kiểu vậy. Ý là nó phân tích kỹ hơn một chút về mấy cái kiểu đã cần cách nó optional các thứ sâu hơn tí.
changes j, increase b1 by very inefficient n nodes in your computation graph and p parameters.
Thì trước thì nó dạy mình hãy optimizer bằng RAM.
This procedure will end up taking n titers. So then I hope thing, and so of my hand manually use calculus to compute the derivatives and then implement maturing of neural networks.
Cái ý tôi muốn nói đây chính là đấy, ý là nó hơi khó một chút là nó mở vào optional rồi, chúng nó sợ người khác không hiểu rồi. Ý là tôi hiểu là cháu pro kiểu đấy, kiểu nó hơi đọc lý của toán, cái này dạy cho kiểu nhập môn thực sự ấy, kiểu mấy thằng không biết cái gì trong đầu ấy. Toán lớp 12 thì mấy cái này sợ không hiểu, làm thế thôi. Rồi, tuần tiếp theo nói gì nữa, check qua mấy cái lab chắc chả có kỹ thuật. Đấy là mục đích của tất cả những gì tôi xem trên xe để biết nó hoạt động như nào, chứ để dùng thì nhanh lắm, nhưng mà ý là những cái để biết mà nó hơi khó một tí thì chúng nó đã giấu rồi, chúng nó optional đây à. Đây là lab optional mà. Hình như cái bài cuối là không có lab. Practice with from multi-class recommend in place of math rejection and also define the output file with in lot. Okay. Survey categorical crop entropy. Multi-class. Hai cái là cái gì nhỉ? Từ vào lại vào cái. Multi-class. Ê, ý là thông báo của tôi chạy đâu hết rồi. Forward mà. Chính xác với cái từ gì? Này. Ừ. Ừ. Zero tôi thấy cái đầu tiên luôn hả?
Hello, my name is Andre, and I've been training deep neural networks for a bit more.
Sao nó dài hai đường xưa? Tôi tưởng một tiền một viết 20-30 phút. Cái 2 tiếng rưỡi. Thế là tôi cũng hiểu tương đối rồi. Để xem cái này còn gì. Đi tiếp. Giờ. À. Yeah, thế ra cái logic này là để uh, Yeah, yeah, nó không giải thích nhưng mà nó bảo là tại vì cái này là short math thì nó tổ chức linear và cái logic là sẽ là raw output. Ý là đây là những điều nói mà nó hỏi nên là còn hiểu thì không giải thích rồi. Advanced apply đủ. Nghe hay đấy. Bias and skill datasets decision tree. Hết rồi hả? Cái em ngoài mới chỉ có một cái cây. Tốt. Rồi. Yeah. Trông hấp dẫn thì giống stream của tôi, kiểu không cao ở dưới màn hình. Dạ, rất là cảm. Tiếp theo là hôm nay tôi phải hiểu tôi đang làm cái gì.
Hi, and welcome back. By now, you've seen a lot of different learning algorithms, including linear regression, logistic regression, even deep learning or neural networks. And next week, you see decision trees as well. So you now have a lot of powerful tools of machine learning. But how do you use these tools effectively? I've seen teams sometimes take 6 months to build a machine learning system that I think a more skilled team could have taken or done in just a couple of weeks. And the efficiency of how quickly you can get a machine learning system to work well will depend to a large part on how well you can repeatedly make good decisions about what to do next in the course of a machine learning project. So in this week, I hope to share with you a number of tips on how to make decisions about what to do next in a machine learning project that I hope will end up saving you a lot of time. So let's take a look at some advice on how to build machine learning systems. Let's start with an example. Say you've implemented regularized linear regression to predict housing prices. So you have the usual cost function for your learning algorithm, squared error plus this regularization term. But if you train the model and find that it makes unacceptably large errors in its predictions, what do you try next? When you're building a machine learning algorithm, there are usually a lot of different things you could try. For example, you could decide to get more training examples, since it seems like having more data should help, right? Or maybe you think maybe you have too many features, so you could try a smaller set of features. Or maybe you want to get additional features, such as find additional properties of the houses to toss into your data, and maybe that'll help it to do better. Or you might take the existing features, x1, x2, and so on, and try adding polynomial features like x1, and you might say, I want to try increasing it. So on any given machine learning application, and a key to being effective things not fruitful, and some of these things out that some it will often turn out that some of these things could be fruitful and some of these things not fruitful. And a key to being effective at how you build a machine learning algorithm will be if you can find a way to make good choices about where to invest your time. For example, I have seen teams spend literally many, many months collecting more training examples, thinking that more training data's gotta help. But it turns out sometimes it helps a lot and sometimes it doesn't. So in this week, you learn about how to carry out a set of diagnostics. And by diagnostic, I mean a test you can run to gain insight into what is or isn't working with a learning algorithm, to gain guidance into improving its performance. And some of these diagnostics will tell you things like, is it worth weeks or even months collecting more training data? Because if it is, then you can then go ahead and make the investment to get more data, which will hopefully lead to improved performance. Or if it isn't, then running that diagnostic could have saved you months of time. And one thing you see this week as well is that diagnostics can take time to implement, but running them can be a very good use of your time. So this week, we'll spend a lot of time talking about different diagnostics you can use to give you guidance on how to improve your learning algorithm's performance. But first, let's take a look at how to evaluate the performance of your learning algorithm. Let's go do that in the next video. Let's say you've trained a machine learning model. How do you evaluate that model's performance? You find that having a systematic way to evaluate performance will also help paint a clearer path for how to then improve its performance. So let's take a look at how to evaluate a model. Let's take the example of learning to predict housing prices as a function of the size. Let's say you've trained a model to predict housing prices as a function of the size x. And for the model, that is a fourth order polynomial. So it features x, x squared, x cubed, and x to the fourth. Because we fit a fourth order polynomial to a training set with 5 data points, this fits the training data really well. But we don't like this model very much because even though the model fits the training data well, we think it will fail to generalize to new examples that aren't in the training set. So when you are predicting price as just a single feature, the size of the house, you could plot the model like this, and we could see that the curve is very wiggly, so we know this probably isn't a good model. But if you were fitting this model with even more features, say we had x1, the size of the house, number of bedrooms, the number of floors of the house, also the age of the home in years, then it becomes much harder to plot f because f is now a function of x1 through x4. And how do you plot a four-dimensional function? So in order to tell if your model is doing well, especially for applications where you have more than one or two features, which makes it difficult to plot f of x, we need some more systematic way to evaluate how well your model is doing. Here's a technique that you can use. If you have a training set, and this is a small training set with just 10 examples listed here, rather than taking all your data to train the parameters W and B of the model, you can instead split the training set into two subsets. I'm going to draw a line here, and let's put 70% of the data into the first part, and I'm going to call that the training set. And the second part of the data, let's say 30% of the data, I'm going to put into a test set. And what we're going to do is train the model's parameters on the training set, on this first 70% or so of the data, and then we'll test its performance on this test set. In notation, I'm going to use x1, y1, same as before, to denote the training examples through xm, ym, except that now to make explicit. So in this little example, we would have 7 training examples. And to introduce one new piece of notation, I'm going to use m subscript train. M train is a number of training examples.
Thì tôi vừa nghĩ là vừa chậm cái nhỉ, nó có khi nào nó mất 1.25 và nó để thành một từ không. Thì tôi chỉnh từ mấy hôm trước rồi, nhưng mà mới lại thấy 1.25, thì nó quá chậm đến mức tôi đang nghĩ như thế. Thôi.
Which in this small data set is 7. So the subscript train just emphasizes if we're looking at the training set portion of the data. And for the test set, I'm going to use the notation x1 subscript test, comma, y1 subscript test to denote the first test example. And this goes all the way to xm test, subscript test, y m test, subscript test, and m test is the number of test examples, which in this case is 3. And it's not uncommon to split your data set according to maybe a 70-30 split or 80-20 split, with most of your data going into the training set and then a smaller fraction going into the test set. So in order to train a model and evaluate it, this is what it would look like if you're using linear regression with a squared error cost. Start off by fitting the parameters by minimizing the cost function j of wb. So this is a usual cost function, minimize over wb of this squared error term doing you, which is equal to the average error on the test set. And that's one actual measure of m, or is this low at that. And the set is actually not so good at generalizing to new examples, to new data points that were not in the training set. So that was regression with squared error cost. Now let's take a look at how you'd apply this procedure to it wasn't a test error 0 straight in the test set. The fraction handwritten digit would be the factor 0. Similarly, in a separate test, being able to automatically choose.
Okay.
In the last video, you saw how to use a test set to evaluate the performance of a model. Let's make one further refinement to that idea in this video, which will allow you to use a technique to automatically choose a good model for your machine learning algorithm. One thing we've seen is that once the model's parameters W and B have been fit to the training set, the training error may not be a good indicator of how well the algorithm will do or how well it will generalize to new examples that were not in the training set. And in particular, For this example, the training error will be pretty much 0, and that's likely much lower than the actual generalization error. And by that I mean the average error on new examples that were not in the training set. And what you saw in the last video is that J-test, the performance of the algorithm on examples is not trained on, that will be a better indicator of how well the model will likely do on new data. And by that I mean other data that's not in the training set. Let's take a look at how this affects how we might use a test set to choose a model for a given machine learning application. So if you're fitting a function to predict housing prices or some other regression problem, one model you might consider is to fit a linear model like this. And this is a first order polynomial. And I'm going to use d equals 1 on this slide to denote fitting a 1 or first order polynomial. If you were to fit a model like this to your training set, you get some parameters w and b, and you can then compute J-tests to estimate how well this will generalize to new data. And on this slide, I'm going to use w1, b1, superscript there, to denote that these are the parameters you get if you were to fit a first order polynomial or degree 1, d equals 1 polynomial. Now, you might also consider fitting a second order polynomial or quadratic model. So this is the model. And if you were to fit this to your training set, you would get some parameters w2, b2, and you can then similarly evaluate those parameters on your test set and get J-test w2, b2, and this will give you a sense of how well the second order polynomial does. And you can go on to try d equals 3. That's a third order or a degree 3 polynomial that looks like this, and fit parameters and similarly get J-tests. And you might keep doing this until, say, you try up to a 10th order polynomial and you end up with J-tests of w10, b10. That gives you a sense of how well the 10th order polynomial is doing. So one procedure you could try, this turns out not to be the best procedure, but one thing you could try is look at all of these J-tests and see which one gives you the lowest value. And say you find that J-test for the 5th order polynomial for w5, b5 turns out to be the lowest. If that's the case, then you might decide that the 5th order polynomial d equals 5 does best and choose that model for your application. And if you want to estimate how well this model performs, one thing you could do, but this turns out to be a slightly flawed procedure, is to report a test set error, J-test w5, b5. The reason this procedure is flawed is J-test of w5, b5 is likely to be an optimistic estimate of the generalization error. In other words, it is likely to be lower than the actual generalization error. And the reason is, in the procedure we talked about on the slide, we basically fit one extra parameter, which is d, the degree of polynomial, and we chose this parameter using the test set. So on the previous slide, we saw that if you were to fit WB to the training data, then the training data would be an overly optimistic estimate of generalization error. And it turns out too that if you were to choose the parameter d using the test set, then the test set J-test is now an overly optimistic, that is lower than actual estimate of the generalization error. So the procedure on this particular slide is flawed, and I don't recommend using this. Instead, if you want to automatically choose a model, such as decide what degree polynomial to use, here's how you modify the training and testing procedure in order to carry out model selection, where by model selection, I mean choosing amongst different models, such as these 10 different models that you might contemplate using for your machine learning application. The way we'll modify the procedure is, instead of splitting your data into just 2 subsets, the training set and the test set, we're going to split your data into 3 different subsets, which we're going to call the training set, the cross-validation set, and then also the test set. So using our example from before of these 10 training examples, we might split it into putting 60% of the data into the training set. And so the notation we'll use for the training set test, where m test here is equal to 2, is the number of test examples. We'll see on the next slide how to use the cross-validation set. So the way we'll modify the procedure is, you've already seen the training set and the test set, and we're going to introduce a new, or some applications be more often by objective. And this new term in the middle, the cross-validation error, is just the average over your MCV cross-validation examples of the average, say, squared error. And this term, development set error, with the count earlier on the slide, with d equals 1, d equals 2, all the way up to a 10th degree or the 10th order polynomial, you can then fit the parameters on your, similarly for the second model, you get JCV of W2, B2, and all the way down to JCV of W10, B10. Then, in order to choose a model, you would look at which model has the lowest short or even the development set error or the dev error. Armed with these three measures of learning algorithm, same as earlier on this set, and you would look at new data. Parameter example will be a fair estimate of the generalization error of this model that has parameter at 50, that JCV of W4B4 is lowest. Then what that means is you would pick this fourth procedure or chose a degree of polynomial using the cross-validation set. And so up until this point, you've not fit any parameters, either W or B or D, to the test set. And that's why J-test in this example will be a fair estimate of the generalization error of this model that has parameters W4B4. So this gives a better procedure for model selection, and it lets you automatically make a decision like what order polynomial to choose for your linear regression model. This model selection procedure also works for choosing among other types of models of small, somewhat larger, and then even larger. To help you decide how many layers should your neural network have and how many hidden units per layer should you have, you can then train all three of these models and end up with parameters W1, B1 for the first model, W2, B2 for the second model, means compute this as a fraction of cross-validation examples that the algorithm has. And since this is a classification problem, JCV, the most common choice would be to compute this as the fraction of cross-validation examples that the algorithm has misclassified. And you would compute this using all three models and then pick the model with the lowest cross-validation error. So if in this example, this has the lowest cross-validation error, you would then pick the second neural network and use parameters trained on this model. And finally, if you want to report out an estimate of the generalization error, you would then use the test set to estimate how well the neural network that you just chose will do. So it's considered best practice in machine learning that if you have to make decisions about your model, such as fitting parameters or choosing fitting.
Ở đây cái này khi tôi xem cái này tôi sẽ kiểu thật dễ hiểu, người ta đã dùng như thế này, nhưng mà cái khó hiểu ở đây chính là mình dùng cái này làm gì nhỉ? Xong rồi lại nghe cái này, ý là đặt bối cảnh người ta dùng như nào thì nào, nhưng mà đặt bối cảnh tôi dùng tôi chả biết tôi dùng thế nào nữa. Phức tạp và khó hiểu thật, ý là phức tạp và khó hiểu nếu đặt trong bối cảnh tôi dùng, còn đặt bối cảnh người ta dùng trời ơi dễ hiểu điên, rất hợp lý, rất make sense, nhân văn ý nghĩa.
Linear regression to make all those decisions only using your training set and your cross-validation set, overly optimistic estimate of how well to automatically choose what model to use for a given machine learning application. Now, earlier this week, I mentioned running diagnostics to decide how to improve the performance of a learning algorithm. Now that you have the most bias, let's take a look at what that means in the
Rồi. Hay là ngủ trưa ta? Phải thật đấy. Chơi chơi cách thích không tốt, chơi nhiều quá rồi. Ngày nào cũng chơi phát. Chơi thế ở nhà cả tuần chết rồi.
More than a decade. And in this lecture, I'd like to show you. Hello, my name is Andre, and I've been training deep neural.
Nhưng mà vẫn có thể làm gì chứ? Không biết cái đấy làm gì rồi, nhưng mà giờ tôi cần data, xong rồi tôi cần data out, rồi tôi phải predict các thứ. Khó quá thì không làm được, mà dễ quá thì không thú vị. Hoặc là code game, hơi đi sai với ôi code game dễ vãi chưởng, cái gì cũng hỗ trợ tận răng ạ. Đấy, cái gì cũng hỗ trợ. Code lên từ đống rác thì khó, chứ có hỗ trợ dễ không. Cả machine learning nhá, trời ơi. Nó nói nửa tiếng về cách optimize, xong rồi thì thực ra là chỉ để thêm đúng một dòng. À, trời ơi, ý là ôi 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 ôi, ý là tôi sẽ không có idea phức tạp đâu. Là có tôi xem quả game, có quả game gì mà nó kiểu không, không đâu. Có cái game gì mà cậu chụp ảnh thế giới, cái thế giới xong rồi chụp ảnh, xong rồi cậu lấy cái ảnh ra cậu đặt đặt nó ra, thế là cái những gì trong ảnh nó biến thành thật luôn, cậu đi vào trong ấy luôn, kiểu trông hay lắm. Trời ơi, cái đấy thì cốt còn gì. Như là vui, tôi đang nghĩ kiểu như này thôi. Này, như này, như đấy. Trời ơi, và lên xeo kiểu có cái đối kháng gì đấy, đơn giản thôi. Nhưng mà dùng cái đồ họa dở hơi dở người này, xong rồi đập một dấu hiệu ứng vào nữa. Thế là khó phần vẽ à? Trời ơi, thế là không khó lúc đấy nhưng mà cũng khó. What the fuck is fun á? À, ok. Trời ơi, ý là có khi tôi làm được ấy, chẳng qua tôi không thích thôi. Tôi vẽ người que từ lâu rồi, chỉ người que thôi. Bây giờ trông cái nhân văn mà làm thêm tí đổ bóng nữa, trời ơi. Mấy luôn. 2D có đổ bóng. 2,5D. Thế có đẹp không nhỉ? Cái cảm giác nó khá hay chứ. Kiểu mặt đất ở đây này, xong rồi thêm một cái này cam từ đó xuống đây, rồi que nó có đúng một lớp thôi. Tôi nghĩ là một lớp thôi nhưng mà thêm tí ánh sáng chiều sâu. Kiểu với que đen trắng thì đổ bóng có đẹp không? Tưởng tượng của tôi nó khá hay. Ôi, đấy nhưng nghĩ là dễ lắm. Trời ơi, làm gì cũng dễ á. Ôi, trông nó khô. Kiểu hướng dẫn đi mắc rồi. Apply. Chứ nó không phải apply. Cái này từ khóa nó apply. Không phải nó apply. Đây nhá.
Neural networks for a bit more than a decade. And in this lecture, I'd like to show you what neural network training looks like under the hood. So in particular, we are going to start with a blank Jupyter notebook. And by the end of this lecture, we will define and train a neural net. And you'll get to see everything that goes on under the hood and exactly sort of how that works on an intuitive level. Now, specifically what I would like to do is I would like to take you through building of micrograd. Now,
Cái đi vào cái micrograph thôi.
Grad is this library that I released on GitHub about 2 years ago, but at the time I only uploaded the source code, and you'd have to go in by yourself and really figure out how it works. So in this lecture, I will take you through it step by step and kind of comment on all the pieces of it. So what is micrograd and why is it interesting? Good. Micrograd is basically an autograd engine. Autograd is short for automatic gradient. And really what it does is it implements backpropagation. Now, backpropagation is this algorithm that allows you to efficiently evaluate the gradient of some kind of a loss function with respect to the weights of a neural network. And what that allows us to do then is we can iterate.
Có cái phụ đề có ưu điểm gì không? Cậu có thể đọc được xem là người ta nói về cái gì để mà tôi nhanh. Còn cái này có phải nghe không? Ôi, ôi, xem tôi tìm được gì này. Có thể bạn chưa biết điều này nhưng mà những người giàu, giỏi và đẹp sẽ không ghét bạn. Người giàu, giỏi và đẹp sẽ không ghét bạn. Người tự tin cũng không ghét bạn. Người thành công thì càng không. Ý là nhân văn nó muốn truyền đạt là mấy cái thằng yếu kém mới ghét người giỏi kiểu kiểu vậy. Ờ, nhưng vấn đề là tôi vừa giàu vừa giỏi vừa đẹp vừa tự tin vừa thành công nhưng mà tôi ghét cái thằng chó. Ôi, ok,
iteratively tune the weights of that neural network to minimize the loss function and therefore improve the
tập
accuracy
trung.
of the network. So backpropagation would be at the mathematical core of any modern deep neural network library, like say PyTorch.
Thế sao giới thiệu về cái thư viện nó viết thôi đúng không? Hai cái thư viện Implement Backpropagation một xíu. Deep
Or JAX. So the functionality of micrograd is, I think, best illustrated by an example. So if we just scroll down here, you'll see that micrograd basically allows you to build out mathematical expressions. And here what we are doing is we have an expression that we're building out where you have two inputs, A and B. And you'll see that A and B are -4 and 2, but we are wrapping those values into this value object that we are going to build out as part of micrograd. So this value object will wrap the numbers themselves, and then we are going to build out a mathematical expression here where A and B are transformed into C, D, and eventually E, F, and G. And I'm showing some of the functionality of micrograd and the operations that it supports. So you can add two value objects, you can multiply them, you can raise them to a constant power, you can offset by 1, negate, squash at 0, square, divide by constant, divide by it, etc. And so we're building out an expression graph with these two inputs A and B, and we're creating an output value of G. And micrograd will, in the background, build out this entire mathematical expression. So it will, for example, know that C is also a value. C was a result of an addition operation, and the child nodes of C are A and B, because and it will maintain.
không bé không biến thành không, đây là gì dấu trừ đâu bé. Để đâu ra này, sờ nó cách nhau, là không giống nhau. Trên này C D C D dấu L C D chắc có âm ở bước ở đâu trên.
pointers to A and B value objects. So we'll basically know exactly how all of this is laid out. And then not only can we do what we call the forward pass, where we actually look at the value of G, of course, that's pretty straightforward. We will access that using the .data attribute. And so the output of the forward pass, the value of G, is 24.7, it turns out. But the big deal is that we can also take this G value object and we can call .backward. And this will basically initialize backpropagation at the node G. And what backpropagation is going to do is it's going to start at G and it's going to go backwards through that expression graph and it's going to recursively apply the chain rule from calculus. And what that allows us to do then is we're going to evaluate basically the derivative of G with respect to all the internal nodes like E, D, and C, but also with respect to the inputs A and B. And then we can actually query this derivative of G with respect to A. For example, that's A.grad. In this case, it happens to be 138. And the derivative of G with respect to B, which also happens to be here, 645. And this derivative, we'll see soon, is very important information because it's telling us how A and B are affecting G through this mathematical expression. So in particular, A.grad is 138. So if we slightly nudge A and make it slightly larger, 138 is telling us that G will grow and the slope of that growth is going to be 138. And the slope of growth of B is going to be 645. So that's going to tell us about how G will respond if A and B get tweaked a tiny amount in a positive direction. Okay? Now, you might be confused about what this expression is that we built out here. And this expression, by the way, is completely meaningless. I just made it up. I'm just flexing about the kinds of operations that are supported by micrograd. What we actually really care about are neural networks. But it turns out that neural networks are just mathematical expressions, just like this one, but actually slightly bit less crazy even. Neural networks are just a mathematical expression. They take the input data as an input, and they take the weights of a neural network as an input, and it's a mathematical expression, and the output are your predictions of your neural net or the loss function. We'll see this in a bit. But basically, neural networks just happen to be a certain class of mathematical expressions. But backpropagation is actually significantly more general. It doesn't actually care about neural networks at all. It only cares about arbitrary mathematical expressions. And then we happen to use that machinery for training of neural networks. Now, one more note I would like to make at this stage is that, as you see here, micrograd is a scalar-valued autograd engine. So it's working on the level of individual scalars like -4 and 2. And we're taking neural nets and we're breaking them down all the way to these atoms of individual scalars and all the little pluses and times, and it's just excessive. And so obviously you would never be doing any of this in production. It's really just done for pedagogical reasons because it allows us to not have to deal with these n-dimensional tensors that you would use in a modern deep neural network library. So this is really done so that you understand and refactor out backpropagation and chain rule and understanding of neural network training. And then if you actually want to train bigger networks, you have to be using these tensors, but none of the math changes. This is done purely for efficiency. We are basically taking scale value, all the scalar values, we're packaging them up into tensors, which are just arrays of these scalars. And then because we have these large arrays, we're making operations on those large arrays that allows us to take advantage of the parallelism in a computer. And all those operations can be done in parallel, and then the whole thing runs faster. But really none of the math changes, and that's done purely for efficiency. So I don't think that it's pedagogically useful to be dealing with tensors from scratch. And that's why I fundamentally wrote micrograd, because you can understand how things work at the fundamental level, and then you can speed it up later.
Tôi cũng hiểu mà. Trời ơi, nó không có gì mới cả. Tôi biết những thứ tôi biết là tôi không biết. Tôi không biết nhiều thứ nhưng mà xem cái này không được kiểu vậy. Nhưng mà cũng thú vị đấy. Để khi nào hiểu biết hơn thì mới xem được. Bây giờ đang kiểu xem để biết chúng nó đang làm trò gì thì cái đấy tôi biết rồi. Đấy, còn cái thể nâng cao từ từ. Rồi, xem hoạt hình đi cho dễ hiểu. Cái này chưa xem rồi. Bây giờ bấm vào xong thấy khó hiểu quá không xem nữa.
Sloppily written and rendered at an extremely low resolution of 28 by 28 pixels, but your brain has no trouble recognizing it as a 3. And I want you to take a moment to appreciate how crazy it is that brains can do this so effortlessly. I mean, this, and this are also recognizable as 3s, even though the specific values of each pixel is very different from one image to the next. The particular light-sensitive cells in your eye that are firing when you see this 3 are very different from the ones firing when you see this 3. But something in that crazy smart visual cortex of yours resolves these as representing the same idea, while at the same time recognizing other images as their own distinct ideas. But if I told you, hey, sit down and write for me a program that takes in a grid of 28 by 28 pixels like this, and outputs a single number between 0 and 10, telling you what it thinks the digit is, well, the task goes from comically trivial to dauntingly difficult. Unless you've been living under a rock, I think I hardly need to motivate the relevance and importance of machine learning and neural networks to the present and to the future. But what I want to do here is show you what a neural network actually is, assuming no background, and to help visualize what it's doing, not as a buzzword, but as a piece of math. My hope is just that you come away feeling like the structure itself is motivated, and to feel like you know what it means when you read or you hear about a neural network quote-unquote learning. This video is just going to be devoted to the structure component of that, and the following one is going to tackle learning. What we're going to do is put together a neural network that can learn to recognize handwritten digits. This is a somewhat classic example for introducing the topic, and I'm happy to stick with the status quo here, because at the end of the two videos, I want to point you to a couple good resources where you can learn more, and where you can download the code that does this and play with it on your own computer. There are many variants of neural networks, and in recent years there's been sort of a boom in research towards these variants, but in these two introductory videos, you and I are just going to look at the simplest plain vanilla form with no added frills. This is kind of a necessary prerequisite for understanding any of the more powerful modern variants, and trust me, it still has plenty of complexity for us to wrap our minds around. But even in this simplest form, it can learn to recognize handwritten digits, which is a pretty cool thing for a computer to be able to do. And at the same time, you'll see how it does fall short of a couple hopes that we might have for it. As the name suggests, neural networks are inspired by the brain. But let's break that down. What are the neurons, and in what sense are they linked together? Right now, when I say neuron, all I want you to think about is a thing that holds a number, specifically a number between 0 and 1. It's really not more than that. For example, the network starts with a bunch of neurons corresponding to each of the 28 times 28 pixels of the input image, which is 784 neurons in total. Each one of these holds a number that represents the grayscale value of the corresponding pixel, ranging from 0 for black pixels up to 1 for white pixels. This number inside the neuron is called its activation. And the image you might have in mind here is that each neuron is lit up when its activation is a high number. So all of these 784 neurons make up the first layer of our network. Now jumping over to the last layer, this has 10 neurons, each representing one of the digits. The activation in these neurons, again some number that's between 0 and 1, represents how much the system thinks that a given image corresponds with a given digit. There's also a couple layers in between called the hidden layers, which digit. There's also the system thinks that a given image corresponds with a given digit.
Cái số này mà 0.97% chắc là số 9 á. Không. 4.
There's also a couple layers in between called the hidden layers, which for the time being should just be a giant question mark for how on earth this process of recognizing digits is going to be handled. In this network, I chose 2 hidden layers, each one with 16 neurons, And admittedly, that's kind of an arbitrary choice. To be honest, I chose 2 layers based on how I want to motivate the structure in just a moment. And 16, well, that was just a nice number to fit on the screen. In practice, there is a lot of room for experiment with a specific structure here. The way the network operates, activations in one layer determine the activations of the next layer. And of course, the heart of the network, as an information processing mechanism, comes down to exactly how those activations from one layer bring about activations in the next layer. It's meant to be loosely analogous to how in biological networks of neurons, some groups of neurons firing cause certain others to fire. Now, the network I'm showing here has already been trained to recognize digits, and let me show you what I mean by that. It means if you feed in an image, lighting up all 784 neurons of the input layer according to the brightness of each pixel in the image, that pattern of activations causes some very specific pattern in the next layer, which causes some pattern in the one after it, which finally gives some pattern in the output layer. And the brightest neuron of that output layer is the network's choice, so to speak, for what digit this image represents. And before jumping into the math for how one layer influences the next, or how training works, let's just talk about why it's even reasonable to expect a layered structure like this to behave intelligently. What are we expecting here? What is the best hope for what those middle layers might be doing? Well, when you or I recognize digits, we piece together various components. A 9 has a loop up top and a line on the right. An 8 also has a loop up top, but it's paired with another loop down low. A 4 basically breaks down into 3 specific lines and things like that. Now, in a perfect world, we might hope that each neuron in the second to last layer corresponds with one of these subcomponents. That anytime you feed in an image with, say, a loop up top, like a 9 or an 8, there's some specific neuron whose activation is going to be close to 1. And I don't mean this specific loop of pixels. The hope would be that any generally loopy pattern towards the top sets off this neuron. That way, going from the third layer to the last one just requires learning which combination of subcomponents corresponds to which digits. Of course, that just kicks the problem down the road, because how would you recognize these subcomponents or even learn what the right subcomponents should be? And I still haven't even talked about how one layer influences the next, but run with me on this one for a moment. Recognizing a loop can also break down into subproblems. One reasonable way to do this would be to first recognize the various little edges that make it up. Similarly, a long line, like the kind you might see in the digits 1 or 4 or 7, well, that's really just a long edge, or maybe you think of it as a certain pattern of several smaller edges. So maybe our hope is that each neuron in the second layer of the network corresponds with the various relevant little edges. Maybe when an image like this one comes in, it lights up all of the neurons associated with around 8 to 10 specific little edges, which in turn lights up the neurons associated with the upper loop and a long vertical line, and those light up the neuron associated with a 9. Whether or not this is what our final network actually does is another question, one that I'll come back to once we see how to train the network. But this is a hope that we might have, a sort of goal with the layered structure like this. Moreover, you can imagine how being able to detect edges and patterns like this would be really useful for other image recognition tasks. And even beyond image recognition, there are all sorts of intelligent things you might want to do that break down into layers of abstraction. Parsing speech, for example, involves taking raw audio and picking out distinct sounds, which combine to make certain syllables, which combine to form words, which combine to make up phrases and more abstract thoughts, etc. But getting back to how any of this actually works, picture yourself right now designing how exactly the activations in one layer might determine the activations in the next. The goal is to have some mechanism that could conceivably combine pixels into edges, or edges into patterns, or patterns into digits. And to zoom in on one very specific example, let's say the hope is for one particular neuron in the second layer to pick up on whether or not the image has an edge in this region here. The question at hand is, what parameters should the network have? What dials and knobs should you be able to tweak so that it's expressive enough to potentially capture this pattern, or any other pixel pattern, or the pattern that several edges can make a loop, and other such things? Well, what we'll do is assign a weight to each one of the connections between our neuron and the neurons from the first layer. These weights are just numbers. Then take all of those activations from the first layer and compute their weighted sum according to these weights. I find it helpful to think of these weights as being organized into a little grid of their own, and I'm going to use green pixels to indicate positive weights and red pixels to indicate negative weights, where the brightness of that pixel is some loose depiction of the weight's value. Now, if we made the weights associated with almost all of the pixels 0, except for some positive weights in this region that we care about, then taking the weighted sum of all the pixel values really just amounts to adding up the values of the pixel just in the region that we care about. And if you really wanted to pick up on whether there's an edge here, what you might do is have some negative weights associated with the surrounding pixels. Then the sum is largest when those middle pixels are bright, but the surrounding pixels are darker. When you compute a weighted sum like this, you might come out with any number. But for this network, what we want is for activations to be some value between 0 and 1. So a common thing to do is to pump this weighted sum into some function that squishes the real number line into the range between 0 and 1. And a common function that does this is called the sigmoid function, also known as a logistic curve. Basically, very negative inputs end up close to 0, very positive inputs end up close to 1, and it just steadily increases around the input 0. So the activation of the neuron here is basically a measure of how positive the relevant weighted sum is. But maybe it's not that you want the neuron to light up when the weighted sum is bigger than 0. Maybe you only want it to be active when the sum is bigger than, say, 10. That is, you want some bias for it to be inactive. What we'll do then is just add in some other number, like -10, to this weighted sum before plugging it through the sigmoid squishification function. That additional number is called the bias. So the weights tell you what pixel pattern this neuron in the second layer is picking up on, and the bias tells you how high the weighted sum needs to be before the neuron starts getting meaningfully active. And that is just one neuron. Every other neuron in the sigmoid function, the input 0. So the activation of the neuron here is basically a measure of how positive the relevant weighted sum is. But maybe it's not that you want the neuron to light up when the weighted sum is bigger than 0. Maybe you only want it to be active when the sum is bigger than, say, 10. That is, you want some bias for it to be inactive. What we'll do then is just add in some other number, like -10, to this weighted sum before plugging it through the sigmoid squishification function. That additional number is called the bias. So the weights tell you what pixel pattern this neuron in the second layer is picking up on, and the bias tells you how high the weighted sum needs to be before the neuron starts getting meaningfully active. And that is just one neuron. Every other neuron in this layer is going to be connected to all 784 pixel neurons from the first layer, and each one of those 784 connections has its own weight associated with it. Also, each one has some bias, some other number that you add on to the weighted sum before squishing it with the sigmoid. And that's a lot to think about. With this hidden layer of 16 neurons, that's a total of 784 times 16 weights, along with 16 biases. And all of that is just the connections from the first layer to the second. The connections between the other layers also have a bunch of weights and biases associated with them. All said and done, this network has almost exactly 13,000 total weights and biases. 13,000 knobs and dials that can be tweaked and turned to make this network behave in different ways. So when we talk about learning, what that's referring to is getting the computer to find a valid setting for all of these many numbers so that it'll actually solve the problem at hand. One thought experiment that is at once fun and kind of horrifying is to imagine sitting down and setting all of these weights and biases by hand, purposely tweaking the numbers so that the second layer picks up on edges, the third layer picks up on patterns, etc. I personally find this satisfying rather than just treating the network as a total black box, because when the network doesn't perform the way you anticipate, if you've built up a little bit of a relationship with what those weights and biases actually mean, you have a starting place for experimenting with how to change the structure to improve. Or when the network does work, but not for the reasons you might expect, digging into what the weights and biases are doing is a good way to challenge your assumptions and really expose the full space of possible solutions. By the way, the actual function here is a little cumbersome to write down, don't you think? So let me show you a more notationally compact way that these connections are represented. This is how you'd see it if you choose to read up more about neural networks. Organize all of the activations from one layer into a column as a vector. Then organize all of the weights as a matrix, where each row of that matrix corresponds to the connections between one layer and a particular neuron in the next layer. What that means is that taking the weighted sum of the activations in the first layer, according to these weights, corresponds to one of the terms in the matrix vector product of everything we have on the left here. By the way, so much of machine learning just comes down to having a good grasp of linear algebra. So for any of you who want a nice visual understanding for matrices and what matrix vector multiplication means, take a look at the series I did on linear algebra, especially chapter 3. Back to our expression, instead of talking about adding the bias to each one of these values independently, we represent it by organizing all those biases into a vector and adding the entire vector to the previous matrix vector product. Then as a final step, I'll wrap a sigmoid around the outside here. And what that's supposed to represent is that you're going to apply the sigmoid function to each specific component of the resulting vector inside. So, once you write down this weight matrix and these vectors as their own symbols, you can communicate the full transition of activations from one layer to the next in an extremely tight and neat little expression. And this makes the... Now is the point I suppose I should say subscribe more on... Anyway, it's just a flirt by looking at data, either being in funding for this video. So, Leisha, one thing I think we should quickly bring up is this sigmoid function. As I understand it, earlier the relative...
Just taking a max of 0 and how function, but if it did, it was very well for these incredibly deep neural networks.
All right, thank you, Leisha.
It uses up.
Không, phải là xong một tiếp thôi. Thằng nó vào animation đây. Một tiếng thì ổn. Animation thì khủng khiếp. Không tệ nào. Không phải về từ xem đâu. Tôi sẽ most realistic entropy. Yeah, I can tell. Nếu cậu muốn nghe về entropy thì nó là đây là nhiệt. Các đại độ nhiệt thì có parameter state. Đấy, cái GTVP đấy, biết rồi đấy, áp suất, nhiệt độ, nhiệt tích, và có thông số trạng thái. Thông số trạng thái là thông số năng lượng. Energy U, lượng năng, internal energy, flow energy, năng lượng đẩy D, enthalpy, năng lượng gì đấy, Y là đơn vị của nó là joule hoặc joule trên kg. Kiểu chứa năng lượng gì đấy, xong rồi khi cậu biến đổi nó thì nó sẽ thay đổi năng lượng. Cái này sang cái khác chẳng hạn, tiêu thụ gì đấy, biến đổi năng lượng. vì nó là run. Như cái này là run trên K. K là nhiệt độ, ý là nó là biến thiên nhiệt độ, ý là infinitesimal heat per instantaneous temperature. Một lượng rất nhỏ nhiệt biến thiên trên nhiệt độ tức thời, và delta S biến thiên entropy nó là cái sự khác nhau khi nó đi và đi về, kiểu vậy. Tôi kiểu cậu đốt nóng, cậu làm nóng cho nó năng lượng đấy, xong nó biến đổi, sau cậu lấy năng lượng ra rồi biến về, thì cái biến thiên entropy sẽ là sự khác nhau giữa lần đi và lần về của nó, kiểu vậy. Kiểu ôi tôi không biết. Không hiểu gì đâu. Ây da, rồi lý do tôi đang tìm một cái nào để xem, nhưng mà có vẻ chả ai làm. Đừng mất tôi xem cái này mà con chó nó chân là sao vậy? Quả open chemical mà, physical chemical science, basic concept of thermodynamics này. Ê, thử quá.
Therm means heat and dynamics means force.
Rồi ở Độ.
So, thermodynamics is surrounding
Giỏi quá.
different ways. When a system is thermodynamic properties are reflective in that is fully identified by the values. Consider a mountain climb.
Ôi ngon quá, bây giờ ủa, sao nay bây giờ về không mà chưa lại một rồi. Bây giờ bỏ chạy tôi đi ngủ. Rồi. Nhưng mà thật tôi nghĩ mỗi ngày chỉ đi học thế thôi. Học từ bỏ bao giờ ăn thì cũng học từ đó 2 tiếng, sáng thêm tiếng. Được 3 tiếng rồi. 3 tiết hơn 3 tiết 4 tiết rồi. Bình thường cơ 2 học còn cái này thế thôi thôi. Đổi tên tiêu đề cái. Stream được 3 tiếng rưỡi à. Trong khi đó đi ăn 1 tiếng. Yeah. Thôi tôi đi học xử lý thôi, cho còn lốt rồi đóng vào rồi hay. Và 2 tiếng rưỡi. Ăn chưa hơn 1 tiếng rồi. Rồi đổi tên nào. 10 tiếng AI là đổi tên thành Neural Network và làm game thì dùng từ như kêu nhỉ? Và C thăng. Được chưa? Hai cái nghe rất liên quan đến nhau nhưng không hề liên quan đến nhau. Nhưng nó lại rất đúng với khỏi clickbait. Đấy là hai thứ tôi sẽ share trong ngày hôm nay. Nhưng mà nếu thằng nào mà xem thì nó sẽ nghĩ là ôi, neural network và C thăng liên quan đến nhau vậy. Chính xác nó chả liên quan đến nhau hết. Tôi đây là. Neural neurals net xin lỗi ạ. Số ít và dây thăng. Trời ơi, nó điên. Neural network và dây thăng. nhá, nghĩa là tôi chỉ đọc qua thôi, C thăng và C cộng khác gì nhau. Tiếp siêu vi đã trốn rồi, tôi phải dùng VS Code. Hồi trước là nó bắt đầu chạm vào VS Code nên là chạy xong chạy qua nó máy chứ. C thăng tôi đọc qua process qua từ web rồi thì sao. Microsoft nó dạng run on .net framework .net thì là what is framework. Ok hiểu. Cái riêng rồi. Console quay lại. Của namespace phải đóng gói vào. Cay nhỉ. Namespace bình thường có thể đóng gói không? Đâu có. Class. Sau class dùng chấm phẩy à? Using thì dùng chấm phẩy. Đúng là biết cách để làm khó người ta. Trời ơi, đọc cái này phát xong đăng video TikTok. Rồi, giận mấy thằng nào nhất sợ chạy luôn. Top 5 ngôn ngữ được sử dụng nhiều nhất. Rồi, xong mấy thằng học Java Schedule. Cái này thì nó bình thường quá, mình phải thao túng dữ liệu, mình phải thay đổi dữ liệu, thao túng kiểu gì đấy. Học Java nào. Ôi, MATLAB tận đây. MATLAB bây giờ. Scrap. Tôi nghĩ Scrap phải được dùng nhiều ấy. Rồi, trong nhân văn điên. Không, nhưng mà ý là Java, Java là gì nhỉ? Chả biết Java là gì đấy. Trong khi tôi có tải Java để chơi Minecraft. Nó cũng không đối tượng đúng không? Nhưng trông y hệt mà đúng không? Chẳng qua cái cấu trúc nó khác thôi đúng không? Chắc chắn máy tôi có Java. Java. Đâu? Trời, hồi bây giờ biết rồi nhưng mà hồi đấy thì còn nghĩ là rồi. Java thì đầu tiên phải có trong máy trên Java. Nó chỉ thế thôi đúng không? Chỉ OP các thứ đúng không? Của output for rất continue các thứ này, đơn giản là class này, đâu căng thẳng hơn tí này. Chả có gì cả, chả hỏi là không có lý do gì học để làm gì. Tôi chưa biết nó như nào thôi. Chỉ thế. Đi xuống này, 26%. Đấy, còn mấy ngôn ngữ web nữa. Đấy, đây là JS là cái gì tôi chưa biết nha, tôi biết có cái HTML. Hồi đấy học document.net, HTML, hello JavaScript. Yeah, yeah, còn JS. Rồi, hồi trước tôi tưởng hai cái này là một cơ. Thì hồi trước nữa, bây giờ biết rồi. Chứ bây giờ biết rồi. Trước trước nữa, 2018. Hồi đấy học HTML mà. Chắc là sao? Không, cái này đúng quá. Cái này thì giờ mình phải thao túng một tí. Rồi sau mới không cho C công cộng là tốt cơ. Thì trong mấy thằng trẻ con nó sợ không? Ý là giống hệt nhau mà đúng không? Ý là con Sol trầm đúng không? Không, ý là mấy cái này giống hệt nhau à, muốn học thì học luôn thôi. Kiểu chẳng có lý do để học thôi. Giờ tôi đọc cái cơ bản nó khác có gì đặc biệt thôi. Chả chả nó sâu, chả cần gì. Dùng có tự biết thì mà. À, Visual Studio. Tôi chưa tải cái Visual Studio đấy. Ừ. Trông vẫn ven nhỉ? Nhiều bước nhỉ? Trời ơi, xe đã xuống. Trước cái xe ở đâu? Nó từng ở đường thứ hai, nhưng đã rơi xuống luôn. Ờ, năm trước ở đâu? Ngoài đường thứ hai, nhưng nó bị hạ xuống. Rồi. Ừ nhỉ? Wow, tôi đã overload rồi. Đổi tiếp thôi. Đổi môn. Học cái mới cho nó có tí dopamine 2 kiểu vậy. Thì mới có năng lượng để học, chứ tôi buồn ngủ lắm rồi. Kia thì cũng bổ ích rồi, tôi nghĩ là 3 tiếng, 4 tiếng thì đấy bổ ích rồi. Trời ơi, một ngày thế thôi, ngày mà được 10 tiếng thật thì ai, còn có một gói thôi từ lần hôm qua gần nhất đấy, cái gói đấy vẫn còn. Nghĩa là cái tình huống để tôi ăn nó chỉ có tình huống kiểu đói đói, buổi chiều đẹp trời tôi thấy đói đói tôi sẽ ăn, nhưng mà cái tình huống đấy không xảy ra khi mà những ngày ở nhà tôi đều ngủ trưa và rồi bữa trưa dậy 2 giờ xong rồi tôi sẽ no. Còn gọi là lúc tôi nói rồi thì là đến bữa ăn mất rồi. Thế cuối cùng bữa trưa Chưa bóc phát à? Ôi, mèo à? Chắc đang ngủ chưa? Ui, tối qua tôi đang ngủ xong rồi nó kêu meo, xong rồi tôi mở cửa xong đi vào xong lên giường nó nằm, nó ngủ đống ở đấy. Ừ. Đấy, thế là buổi tối nó ngủ, buổi sáng sẽ chạy, cả buổi sáng nó chạy đồng đồng nó không ngủ. Đấy, thế là chạy cả buổi mệt, đến buổi chiều lại ngủ. Ok, thì là AI thế thôi, code game vậy. Ngày mai chắc là học một khác, bắt đầu học bổ ích hơn, cái kiến thức cần thiết hơn. Thì ra mấy cái môn trên trường đấy, xong rồi research một chút nữa, chưa research. Mua đồ làm mấy cái project. Trời ơi, còn trên AI nữa, chết rồi, cho con học quá. Tôi phải train con AI để mà cho trong cái mini project. À, online đúng không? Comment là quan trọng. Ok, variable type in. Ok, cái này dùng C. Constant là gì? Override. À, ok. Ý là nó không quan trọng đâu đúng không? Mình cứ sửa được mà. Online. Ok, data type. Đây là mình có cái đây biết rồi. Operator, mass string, string, XL, XL là XL, if một, hay C cộng cộng, switch dùng hết à? Break continue cũng thế thôi. Break, ok dùng hết. Đấy học anh mà. Chỉ cần nó có trả mới. Có ai định nói gì về cái static void này không? Có. Đây tờ chắc là return value. Void main mà. Hay đấy. Hàm luôn. Ok. Return value. Ok, ok. Đấy, ok. Ok. Rồi, hồi học C cái này khó hiểu điên. Hồi chưa bỏ chạy rồi. Hồi học C ấy, trời ơi, chả hiểu cái này là muốn nói cái gì. Xong học linh cái không nhớ phải nhớ. Ý là cái nào cũng thế mà nó chỉ có mấy cái lệnh cơ bản Excel cấu trúc. Nhớ lướt command để biết thôi. Rồi cái sau đó lúc giống xây một cậu đi nhanh cái gì đâu. Không, tôi đang muốn nói là cái hồi trước ấy, tôi học class ấy, trời ơi, cái hồi học C ấy, hồi đầu tiên ấy, học class không hiểu một cái gì. Nó cứ nói bắt mình làm cái gì không chả hiểu mục đích nó làm gì. Kiểu bắt mình lập danh sách lớp rồi các thứ rồi cũng làm theo thôi. Hiểu. Đấy, nhưng mà đến khi học English, trời ơi, hiểu sâu sắc luôn. Ngon, được rồi. Phong cách, chị bước đi mà chẳng phong cách. Số bên là trong glass vậy. The fuck?
9620320 7124662.
Say over, say đâu tới mai, một cái mà kia ta đừng cay. Nước còn không to thì nó có to nhưng mà đủ đã. Không.
Tiếng gió to thế. Bây giờ xe stream thì tiếng gió ở dưới tầng 1 nó vọng lên.
Có tiếng à? Tiếng vào. Luôn à?
Nghe chúng ta có thể làm tin luôn.
Thế thôi.
Thì đọc qua là không được đọc không? Để view.
Thế nhưng mà tại sao?
Nếu cần gì mình sẽ hỏi.
Tại sao? Tại sao main ở trong class?
Hả?
Sao Bên là trong class. Sao class không có chấm than?
Là thật.
Chấm phẩy. Đấy, bình thường main phải ngoài class chứ. Class xong rồi chấm phẩy.
Cái này thì không có chấm phẩy, cái là nó chỉ bảo một đóng ngoặc mà nó không có chấm phẩy.
Nhưng mà bình thường nó phải ở ngoài class chứ. Ở ngoài class là C cộng cộng.
Nó có một cái thiên thìn kiểu example.
Yeah.
À đúng rồi, main ở trong class. Yeah. Nó có cái trò đấy. Nó trong một cái class chính.
Ok, vừa làm bên thôi. Ôi, vẽ thì vẽ bằng gì nhỉ? Vẽ đâu phải tôi vẽ bằng bên đó.
Vẽ thì đâu. Nó ra asset này. Riêng 2D à? Riêng 3D thì ai?
Và đây nó vừa khó vừa không có nhu cầu lắm. Unity 6. Nói gì nữa?
Sao hỏi Unreal đi này thì mình có thể dùng C cộng.
Định rồi đấy, xong mở lên nó có hướng cái nó là tutorial tải. Hướng dẫn tải. Mở lên download một cái tích doc editor 35 GB, xong rồi thêm một số thứ nữa 15 GB. Rồi khiếp luôn. Gì đây?
Mà nhẹ hơn này. Unity nhẹ hơn đâu rồi.
1/10. Thế là mấy cái khác mình cứ lung tung nữa, kiểu có set có ship gì đấy. Tên này. Có ghép, có dot.
Ôi không.
Cái này có 500 mê thôi.
Mà cần làm đéo rồi.
Đấy, đang nói đây. Cái này 1/10, xong mấy cái khác bằng 1/10 cái này nữa. Anh chỉ 50 GB ạ, chưa làm gì cả 50 GB rồi. Một hồi bấm đây à?
Xuyên sò.
Đâu rồi? Đâu là không rồi. Đâu này rồi. Đâu bấm đây à? Asset các thứ, asset store. What the fuck? Không phải câu đâu nhỉ?
Không. Nãy có 2 người xem mà.
Không ai phạm. Mấy bạn hỏi rằng nếu rồi network và C thăng liên quan tới nhau, nó chẳng liên quan tới nhau cả. Nãy học này rồi network bây giờ học C thăng. Clickbait đấy. Sample. Call. Remote packet mà.
Ủa, cá lọc này.
Sắp cái gì tách tè tua có ít function.
Rồi.
VR. Đi vào trong hai đây là
Lên YouTube chưa?
trời ơi, nhiều thứ học quá nhỉ. Còn YouTube về đi tìm.
The feature examples sample is a collection of over 30 shader graph files. Each file demonstrates a specific shader technique, such as angle blending, triplanar projection, parallax mapping, and custom lighting. While you won't use these shaders directly in your project, you can use them to quickly learn and understand the various techniques and recreate them in your own work. Each file contains notes that describe what the shader is doing, and most of the shaders are set up with the core functionality contained in a subgraph, so it's easy to copy and paste directly into your own shader. The sample also has extensive documentation describing each of the samples to help you learn. After importing the sample set, you can quickly and easily browse the samples by opening the scene that corresponds.
Hi, I'm Mark Brown, and I am making my own video game. And so, to start, I need to learn how to make video games, which is quite a big endeavor and quite a big challenge. So, believe me when I say that this whole game making, let me tell you what, a game engine. Now, a game engine, at least in this instance, is of the stuff to render. Plus, they have loads facing with a controller, doing physics calculations and more. Plus, they have loads of really handy tools that are specifically designed for the things that you'd want to do in a game, like animation and UI. Now, there's loads of game engines out there. I mean, the most popular ones are Unity, Unreal Engine, Godot, Pico 8, Game Maker, Construct. Plus, there are game engines for specific types of game, like Twine, RPG Maker, and Adventure Game Studio. There are even game engines for specific ecosystems, like Game Builder Garage on Switch, Dreams on PlayStation 4, and Roblox in the Robloxiverse. Each one has pros and cons, lovers and haters, but ultimately I had to just pick one, and so, in the end, I decided to go with
Nhưng mà nó biết làm. Ra thế đó. Cũng biết rồi. Đã yêu em từ lâu. Mình đi cho mèo nhé.
Ăn này.
Yeah, nó biết đấy, nó biết thì nó vở thôi, nhưng mà không phải ăn thì nó chả phải đứng rồi. Biết nhưng mà quyết định phản ứng hay không, ăn xem nó quyết định phản ứng sợ từ ăn với sao cũng sợ.
Unity. There's loads of reasons why I chose Unity. It seems to strike a pretty good balance between being very powerful and relatively easy to learn. It's good for a game, and I followed along diligently. Every time they clicked a box, I clicked that box on my screen. And every time they typed, as I said, step 1, done. Pick a game engine. Tick. Now, step 2, learn how to use it. That's the hard bit. And so, as I said, there's lots of tutorials for Unity out there, and that is exactly what I tried to use when I first started learning it. I went onto YouTube, I typed in Unity tutorials and found a bunch of, Swedish men who could teach me how to use the software. And so they showed me how to make a game, and I followed along diligently. Every time they clicked a box, I clicked that box on my screen. And every time they typed out a line of code, I type out the same line of code. And before long, I had a working game on my computer, which was super exciting. But then, many weeks later, I decided to open up a blank Unity project to kind of see what I had learned. And the answer was nothing. Literally nothing. Everything they had said had gone in one ear and out the other. I couldn't even make a character appear on the screen and move around. It was terrible. And ultimately, it was my own fault. Do you remember that video I made about tutorials where I talked about how in strategy games they have those arrows that say click here, click there, and they're not effective at teaching people at all? Well, I had done exactly that for Unity. I had played myself. I had done myself dirty. But to be honest, this was really demoralizing. I truly felt like an idiot. I had wasted weeks of my life, and I didn't know if I was even cut out for game development at all. If I can't even watch a tutorial and have any of it sink in, then maybe I'm not cut out to do this. Maybe I should stick to what I know. And I mean, this was months ago, and I was planning on doing this series. But then I thought about Adobe Premiere. This is the software that I use to make all the videos on this channel, and it's a pretty complex piece of software, and yet I know how to use it, and I know how to use it pretty well. So how did I learn Premiere? Well, when I was working at Pocket Gamer, we had to do these very basic video reviews, and so a colleague taught me the basics of Adobe Premiere, just the absolute baseline knowledge you need to make a video. How to import clips, put them on the timeline, apply really basic transitions, and export them to YouTube. Then I had to make dozens of these video reviews myself, and so I had to repeat those basic steps over and over again as they slowly wormed their way into my brain. Then I made Game Maker's Toolkit, and at that point I wanted to do more interesting stuff with video. I wanted to do masks and color and text and transitions and motion graphics and all that fun stuff. And really that should have been very difficult to learn, but I had two things on my side. One is that I don't need to learn everything all in one go. As long as I'm always trying at least one new thing in each video I make, I can slowly build up a repertoire of effects and knowledge. And two, because I had done those video reviews, I had become really familiar with Premiere. I was comfortable with the software, and so whenever I wanted to try something new, I felt I could experiment and play around, or at the very least I knew what I should go and type software out so that the number I have both possibly crop up and it's impossible programming, or at least that's what it said on my Tinder profile, so I know about if statements and for loops and functions and stuff like that. And I have dabbled in Game Maker, so I kind of get how game engines work, sort of. But I do need to understand stuff like that. I also found basically like an invisible container with a position, rotation, and scale, which you can then fill with components to make it do stuff. That includes a sprite renderer to give it an image, a rigid body to give it physics, a collider to make it hit into things, and, most importantly, a script to let you write programming code for it. Once I had that in my brain, I put together a list of things that I would really need to know in order to make games. Things like, how do I make one game object talk to another game object? How do I spawn in new game objects, and then how do I delete them again? How do I make something happen when two game objects collide into each other? How do I do UI and sound effects and animation? How do I deal with levels and game over and things like that? So then I used tutorials and Google and talking to people to kind of answer those questions and figure out the basics of Unity. And sure, there are probably plenty of Unity people watching this right now who think that is not a very comprehensive list. That is not going to get you very far. And there are probably, no, definitely, better ways to do all of the things that you have just learned how to do. And yeah, that's true. but it's enough to get me started. I can make stuff appear on the screen, make it move around, make collisions happen, spawn things in, delete them again. These are things that are fundamental to how games work, and they are these kind of genre-agnostic things that I will need to know no matter what I make going forward. It is the baseline bedrock that I can use to start building from. And so, with that, I'm on to step 2.
Bedrock của danh từ bedrock là có phải một nó là một kiểu từ hay là
Nó là một từ mà
bedrock cái số
nó đá nền đấy.
Để trong tự nhiên tồn tại đặt tên hả? Under surface. Nó là danh từ để ám chỉ một solid foundation. Đây là câu hỏi của tôi là how strong is bedrock in real life?
Really prove that I understand those things and to really familiarize myself with them by repeating myself and making simple projects. And I found in an infinite number.
Những cái bên phải là trông như nào? Giới thiệu đi.
Phía cái video thứ hai.
Tôi xem rồi. Khi nào?
So we want this function to trigger when the bird crashes into a pipe. Back on the bird script, let's reuse that code from before to access the logic script from pain. Everything is essentially an inverter one. Some of this stuff will be made in Unity as we go along, but we can also just drag and drop files from elsewhere on our computer. Like, I've made some sprites for the bird and the pipe in Photoshop, and I'm going to import them into my project like so. You can also just sprite scene, which in
transparent được, mà transparent thì đúng chỉ có PNG. JPEG không transparent.
Ý tưởng đã, từ từ. Ý tưởng. Ê. Tôi nghe tiếng nhóc nhép với tiếng nhóc giọt nhá. To đấy.
Rơi gì đấy.
Hơi to, nhỏ chê nha. Nhỏ quá nó biết chê mà. Này cũng gọi là kẻ ăn đấy. Không hề. Thế là ăn thì nhiều, nhưng mà ngại thức ăn đấy. Đây cứ đem pate về hạt thẳng ơi, đó hết.
Idea. Idea. Idea là gì?
Một thằng người quen. Thế bằng nút đánh. Sẽ chém. Xong có một con boss chạy quanh quanh. Camera lốc vào người chơi. Chém cho con boss bị hất ra. Thêm thành màu nữa.
Bị hất ra.
Con boss thì nó con quái nó bị hất ra rồi nằm lăn que đấy. Đấy. Con hồi máu cái gì đấy. Hoặc sao thanh máu tự trưng thôi. Ok, thanh máu tỉ máu chẳng hạn. Mình chém thêm 10 đam. Đạo nó khó lúc rồi. Nhấn chạm vào một cái dao. Nghe cũng không dễ đâu. Mấy người không làm game trông có sàn, nhưng mà mấy người đã bắt đầu làm thì nó khó biết. Về thì chơi bạn. Hoàn màn. Click bằng hit. Tag. Bằng damage. Camera lúc vàng. Chắc chắn rồi, cắt được giấy không rồi. Nó F3. Ok. Copy trò chính.
Most games will be a level. We're going to start by making, that's always more fun, but if you can also just drag and drop files from elsewhere on our computer. Like, I've made some sprites for the bird and the pipe in Photoshop, and I'm going to import them into my project like so. I'd recommend you make your own, that's always more fun, but if you have zero artistic ability, then check the description for these assets. The next panel is the hierarchy. This contains all of the stuff that's in the current scene, which in most games will be a level. We're going to start by making the bird, so right-click and choose Create Empty. This has made an empty game object. So, what's that? Well, a game object is essentially an invisible container. It has a position in space, a rotation, and a scale. Then you can fill that container with components to add extra features. For example, if we add a sprite renderer component, we can slap the bird image onto the game object. Absolutely everything in our level will be a game object with components. The bird, the pipes, even the user interface, and the camera.
Đó, thằng này cái thằng này nó vừa làm video nói về việc không nên xem tutorial và nó vừa làm một tutorial.
All of this magic happens in the third panel, the inspector.
Nghĩa là cái tutorial typical mà tao xem mà nó không hướng dẫn kiểu này đâu. Nó sẽ kiểu mày hãy làm theo tao đúng từng bước và nó sẽ thành một game.
Bánh nữa rồi.
Tao từng làm kiểu duty và nó hướng dẫn là cái anh bên trái bên phải. Rồi không biết gì luôn.
Which is for messing with game objects. So once we've selected our new empty game object, we can put a name in the top field. Let's call it bird. And we can see and change the game object's position, rotation, and scale under transform. We can now press add component, pick rendering, and pick sprite renderer. To make this work, we need to fill in the sprite field. So just drag the bird image from the project panel into the field and voila. We have graphics. That will, of course, show up in the fourth and final panel, the scene view. Here we can see what's in our current scene, and if you want, you can use these tools to move stuff around, scale it, and so on. This section has an extra tab for game view, which shows us what the game will look like from the main camera when it's running.
Bình thường mày. Đây có số đó không? Con bé trèo được. Nó là bịch to mày ăn.
Also, from this drop-down, we can set a resolution or aspect ratio to get a better idea of what it will look like when played. So I'm going to choose 1920 by 1080. Oof, the bird takes up way too much space. We could scale it down, but let's actually just zoom out the camera. Like I said before, the camera itself is a game object in the hierarchy, and it has a camera component with stats we can mess with. By changing the size, we can zoom out. I'm also going to change the background color. Lovely. We can now press the play button up here to start the world's most boring game. Okay, let's make it a bit more exciting. A quick recap. Unity has 4 panels by default. Project holds all the stuff in our game. Hierarchy lists all the game objects in the current level. Inspector lets us see and change those game objects, and we can see the level in the scene view. And a game object is an invisible container that we can fill with components like a sprite renderer. In step 2, we're going to use more components to make the bird into a physics object that is affected by gravity. And then we're going to write some programming code to make the bird fly up when we press the spacebar. So let's add another component to our bird, a rigid body 2D. This turns our bird into a physical component code to make the bird fly up when we press the spacebar. So let's add another component to our bird, a rigid body 2D. This turns our bird into a physics object with gravity. So when we hit play, the bird drops and falls off the screen. Cool. We'll also want this bird to be able to interact with other objects. So let's add a collider, a circle collider 2D. Back in scene view, we can see the collider as a green, a circle collider 2D. Back in scene view, we can see the collider as a green outline. It's a bit off-center for me, so I'll use the offset to move it. And a little game design trick. If we make the collider a bit smaller than the image, it will let the player get through the pipes even if they just touched the edge. It gives the game a bit of leniency and makes it feel more fair. The final thing to add right now, a script. This essentially lets us make our own custom component, but we'll have to write it ourselves using programming code. Choose New Script from the components list and call it Bird Script. Once it's loaded, double-click the script field to open it up. This will open the file in Visual Studio, which we installed earlier. So, welcome to programming. It's not too scary, promise, we'll take it slow. We're writing in C. Open the file in is loaded, double-click the script field to open it up. This will open.
Một cái là vô rồi mình vào cái nào nó hiện tu rồi.
Có tôi à?
Không, không. Tải thôi. Đâu có thể có nó gì đâu.
Đi hình như có VS Code, VS Studio cho Unity ước tải
Tại sao lại có gọi là free studio?
Nó có bản
thì không free à?
Có bản
À đúng rồi, giờ tải nó hỏng. Tí thứ. Ok. Này thôi. Đâu? Hay rồi. Rồi cái túi bị lát hả? Bị lát nhỉ? Bỏ lưỡi xuống. What the fuck? Sao nó báo lúc đinh rồi? Trong khi ta chưa chuyển ổ.
nó đang installer.
Nó phải cho chọn ổ chứ. Cái Microsoft Teams nó nặng hơn ghi mà nó không cho tôi chọn ổ. Không cách nào để chuyển. Rồi. Rồi. Gaming mà game development Unity mà. Cái này thôi à? chân bàn chân đó không phải kiểu lúc mà người ta có thẳng nguyên thì biết rồi thì một dạng nhỏ lần có lúc là cả lưng thì đánh em được chín dấu ấy mèo người ta cũng chẳng mobile development .net desktop development Hey, what the fuck yeah nó cá chê ý Excel and xe computing tool giờ mỗi cái một vị trí thôi là không vậy chọn chỗ rồi bây giờ đổi chỗ thì có sao sao
Thì đến nước đổi rồi. Em giờ là nước đổi.
nó tạo mẹ rồi hay
Nó mà chưa tạo. Tạo
còn nó đã có tạo cái Visual Studio này kép của Bootstrapper này.
Cũng bóng chung nhỉ?
Là quên mất rồi tôi
Đúng, điều xịn.
theo anh nhá Ôi. Đóng cửa tí thôi mà phòng một cà thế.
phải tìm lại vào để mình làm.
Đóng cửa cho gió thông. Không sao đâu. Sao con anh treo cổ đây? Sao anh treo cổ này? Làm gì với chị? Không biết làm gì vậy. Rồi, có cái xích mùa này trong số con nhất thổi ra ngoài chắc chắn lắm.
Số con nhất ở ngoài.
Đẩy khí nóng ra ngoài khí lạnh hút được không?
Mùa này nóng được.
Trong phòng sẽ nóng không biết nhưng mà một chút nữa là nó một ngạt ngay. Đây không điều hòa thì điều hòa thì không thể điều hòa. Hôm nay không ai có điều hòa mà trời cho lạnh thế. Nó cần nhiệt độ trong phòng bằng ngoài trời. Cho hết được một file có sao nhỉ? Bây giờ mấy cái này nó phân nhau, nó chia nhau thành đồng file khác nhau, nhưng bây giờ ném hết được file. Xung đột thì mình tính sau ha. Ý là đây nó có 3 lựa chọn nên nó đều vào các file khác nhau, tôi ném hết tất cả vào chung một file. The root installation path cannot overlap package cache path. Đó.
Cái đầu số cái phần nào là tổng bao nhiêu nhỉ?
84. là một cái ca tre này. Một cái đống là cá tre hết rồi. Mà không biết được lúc nào mở cửa ấy. Cửa sổ nó mở nó sẽ lên. Không nhưng mà người đi đâu ra theo đầu cuối đâu. Đầu thơm cho đi. Bình thường. Đây là gì? Đừng nát nhau. Người khác đấy. Đây hồi tốt. Một cá tre của số Lý Quốc. Phải vậy. Cá tre như nhàng. đây đó là 2022 rồi, 2025 nơi rồi. Ngay quê điên. Ủa, sao lại hay vậy? Ngon. Bây giờ install lên. Ủa xong cái gì? Ủa xong rồi. Rồi gì ra? Đã rồi đúng không? Đi đúng không? Đi cho sâu. Đi đâu? Không ngồi đâu. Móng mà cũng là sau đấy tôi cắt tớ rồi. Thì, khi nào mà nó bám nào thì người ta phải từ ta. Ôi cẩn thận nha, tôi thấy cái mic nó nhảy nhảy. Lâu nhảy phát rồi sao? Lâu nhảy phát. Đây, bây giờ thì xong rồi.
Nói là mình nói rồi đấy.
Không, cái lúc mà không có gì nó kiểu nó nhảy nó phát nhảy phát.
Không nhận ra đâu.
Chúng ta một hai từ từ sao? Start engine lâu vậy? Lâu cái lần nào lâu vậy? Thấy không? Hồi nào bè ông miếng thì nói lắm rồi. Bây giờ mấy thế? Nhau rồi nhau. Cho ra ngoài nhé. Sao? Mèo gì cho ra? Mèo đi. Cho mèo ra nó. Mèo không ra đâu. Mèo thôi. Asset. Global Light 2D. Không, tôi bắt đầu chụp cho nó xem. Nhưng mà tôi
theo cũng từ ngày thử thách một ngày không được vứt nó lên thầy
ơi,
sẽ cực kiểu phải nóng ấy hay làm thử rồi. Đó. Siêu tập trung kiểu thức tỉnh siêu xe đây.
nhưng mà không. Đây đó. Ủa, đi ra rồi. Đây không bị chỗ máy rồi. Đẩy cửa ra. Chờ phát yên. Chờ đây, chờ đây. Hoàn toàn ghét lá luôn. Đây rồi, mềm rồi. Download. Background.
Background là anh em không phải là màu đơn lẻ.
Dạo gần gần làm cho nó biết. Khỏi ngủ đấy.
Yeah.
Raw Live 2D. The fuck is this? Đeo tai nghe hoài. Nghe. storyboard các bạn. Bây giờ xóa storyboard không qua document. Trong máy có một chỗ gọi document.
Yeah.
Rồi. Đâu có gì. Bằng không. Đúng không? Import package. Nhưng mà what the fuck? Okay.
This magic happens in the third panel, the inspector, which is for bring components, the game object, we can put in the with components, the empty object, like so. I'd recommend you make your own, that's always more fun, but if you have zero artistic ability, then check the description for these assets. The next panel is the hierarchy. This contains all of the stuff that's in the current scene. Right click, so as a container, a component will be, and that's for messing with game objects. So opens in the third panel, the inspector, which is for messing with game objects. So once we've selected our new empty game object, we can put a name in the top field, let's call it bird. And we can see and change the game object's position top field. Happens the absolutely sprite contains positions that well, again, this is made is an extra component. This magic happens in the third panel, see and change the game press work to the field fourth, and if you extra when it ratio 10 let's act in changing this boring game. Okay, let's make it a bit more. If you want, you can use these tools to
Cái này chắc phải nhiều thứ quá.
Thì phải làm background.
Không, cách để mà sai là con người.
Rất sai là người ấy.
We making game today. Where we are. Dần.
Nếu thế phải mỗi bộ phận là một sprite đấy.
Yeah. Tôi cũng đoán thế, nhưng mà bây giờ thì cứ một cái đấy chưa tách ra. Một cái gì tí tách ra thì cái kiếm gì đấy bay. Ok. I want man work on survey today. What component are you? Rigid body 2D.
Nghĩ là tao vật tí nữa.
Cho cái script vào Collider 2D. Collider capsule collider around the character to define physical boundary. Tức là một cái là vật lý, một cái là va chạm. Cái là hình ảnh nữa.
Sprite renderer đúng không?
Sprite renderer.
Nãy mình dạy hết mấy đấy rồi mà.
Cái đấy biết rồi, riêng cái đấy biết rồi, nhưng mà tôi đang nghĩ về những cái khác nữa, tại vì cái game đấy nó chỉ có con chim và cũng là bay thôi, nó không có va chạm, chưa có va chạm. Một đoạn sau ấy đó.
Khó nói. Ông ấy khó nói đến đoạn collage mà.
Tôi biết nhau. Nói gì nữa. Gì đâu nhỉ?
Component.
Sẽ có tính chất là đó. Tôi đang cho con physics thôi, mình kia tính sau.
Cái gì tính sau?
Rigid body đâu. Đừng chạy rơi đúng không? Theo như điều kia nói.
Từ rồi.
Trời ơi. Đó. Xong rồi.
Ở đây nó tăng cân để cho nó rơi nhanh hơn.
Max. Dumpling. Dumpling là gì? Ai đoán trước được rồi hả? Dumpling. Sóc. Sóc. Giảm sóc. Nhưng mà chỉ số sóc ở đây cái là hệ số sóc. Nó chẳng có ý gì cả, tôi chỉ để nó quen.
Dumpling.
Nhưng nó giảm, nó đúng nghĩa là giảm sóc. giảm những cái vibrate, bass, các thứ. Giảm rung lắc là sao? Giảm nhiễu, cái gì đấy. Hệ số rung. Ôi, may tôi giỏi lý, trời ơi. Thằng nào nó không biết cái chữ nào vào đây học. Thằng ngồi học lý rồi chết mẹ luôn. Tôi phải làm gì thằng người này.
Move stuff around, scale it, and so on. This section
Okay. Wow. Sao lại scale mà aspect ratio. Còn hai bên này sẽ kéo hai bên. Nó sẽ thu rác xuống. Ok, khá dễ hiểu. Transform tool. Wow. Hay vậy. Mỗi tôi thấy biết là gì đóng.
section has an extra tab for Game View, which shows us what
Game view.
the game will look like from the main camera when it's running. Also, from this drop-down, we can set a resolution or aspect ratio to get a better idea of what it will look like when played. So I'm going to choose 1920 by 1080. The bird takes up way too much space. We could scale it down, but let's actually just zoom out the camera. Like I said before, the camera itself is a game object in the hierarchy, and it has a camera component. Instead, we hit play. Worry about right now is these two chunks here, start and update. Start using programming, dumb code is, so we now have a slot to back in Visual Studio. One would be a good one. I'm going, and now look at all the
chắc là với sàn chứ. Thằng này chắc là nó không có sàn rồi vì nó không phát pilot.
Nếu mà thế thì nếu mà làm camera lock vào người chơi là không phải là
bình thường mình trước là nó có cái camera nó bay sang đằng sau cho người chơi. Game game khá nó cũng camera không phải lốc vào người chơi mà nó đi theo người chơi. Nó có một số lý thuyết đó để quan sát trước hay gì đấy không để giữa rồi cái thứ rung lắc theo
cách để góc trái góc phải bao nhiêu nó sẽ di chuyển camera.
cũng một đồng lý thuyết đấy, là lốc vào người chơi cho nó. Yeah.
Mình di chuyển kiểu A hoặc là B thì di chuyển C cái không của người chơi thì người chơi thì có gì đứng trước màn hình.
Cho nó rồi kia đó là nó ra có người tóm cổ tôi vào đi. Hơi khó đấy. Tôi làm hơi nhiều lần rồi nó muốn vào nó vào rồi phải đâu rồi phải làm ra cái mặt đất. Hello, có ngoài sân đó thì dễ rồi. Vừa ở đây thằng nó bây giờ tôi muốn của nó cũng đường vật lý ở đây. Gây đường.
Cái hình chữ nhật là cam à?
Tôi đoán thế, tại sao nó hình ở đây? Đây là cam chứ đúng không?
Không.
Sao nó hình trăng đây?
Sao bên kia nào? Ấn cái sao bên kia xin đấy. Đúng cam à?
Nó cũng hình rất là khó hiểu ở đây. Đây là chỉ có thể là cam, chỉ có thể là cam. Mình hơi nhạt nhẽo nhỉ. Physics. Tôi cần cái gì đâu. Hai con này hai. Thì con này đâu xa đúng không? Em quay.
Nó
Rất là mới sai.
cái đây nó cũng không có rigid nữa. Nó không phải là rigid body. Hoặc là gravity của nó phải là không.
Nhưng mà rigid để con này đâm vào đây. Bây giờ cả hai con đều là rigid thì
Yeah, phải cốt để cho chạm. Con không ạ.
cũng được có. Phải có cái gì đấy khiến nó
Mesh collider. Từ cái này là gì? Hay. Nha, mình có thể đổi tí này. Vứt cái này đi. Remove component. Không, cái là physics 2D chứ. Mình là physics 2D chứ. Mình sẽ có cái gì collider? Platform vector. Thử xem thế nào mình tìm.
thử với sai gì nhiều.
Từ thế thì nó là cái gì nhỉ? Cái gì collider nhỉ? S. Yes. Yes. Nhìn giống ấy, mình nghĩ là kiểu nó chạm vào đây sẽ dừng lại. Từ đấy.
Giữa luôn à?
Đoán thôi.
Xong rồi phải thêm con collider với con kia. Con này tạo dynamic cho nó thì tạo collider. Các collider.
Đúng rồi nhỉ, là chưa collider như vậy nên mình phải thêm code chứ. Collide rồi thì làm gì? Hay.
Nó Sau programming kiểu ít di chuyển thì chuyển script vào con này. New script. New
character
bật cái đấy là như nào nhỉ?
Component now has a field for a rigid body 2D. We can drag the component into that slot body.
Đồ Visual Studio. Ôi, đó rồi. Sắp thành pro rồi. Ngồi chứ vất vả đi, không dễ đâu.
keyboard.
Okay.
Download
Đặt cái blue đó.
blue là kiểu màu classic của VS Studio.
Okay. Tại sao cái này màu trắng? Có cái nào đổi đúng không?
Không, nó đã đổi mà.
Cái này cơ.
À có. Bớt từ cái này.
Nó không nên thế đúng không?
Cái Windows đang để ra mode đúng không?
Yeah, chắc chắn rồi.
Thế là thế.
Đây. Mua rồi. Yeah, chắc chắn rồi. Rất trắng rồi, nếu mà không ai để trắng là cả cái này trắng. À. Tiếp. Làm gì cho kết nối nhá. Assembly.
Assat to Unity.
Oh. Có nguyên một lúc là attack Unity mà.
Nguyên đoán không? Yeah.
Đi, hết cô nào lên nào coi. That's it. From review with you have to work also recompile on script.
Về cơ bản thì như là về trả cần.
Chẳng quan trọng.
Trả cần VS Studio. Mình chỉ cần load back là được. Nhưng mình pro mình thấy code rồi mình không cần chạy. Rồi vào đây chạy một phát, chạy xong mình ấn lại ấn lại cái book.
Đúng không? Using class ở ngoài có thêm hai cái thằng con rồi.
Class là tên của tên file viết lại. Oh.
And then we're talking is a built-in. We'll be doing this tag, layer, and name. So let's pick name, then write an equal sign, and in quote end of a. Now when we run, okay, we can write a command by choosing someone to talk to, and then a command. So what we actually want to do is, in the rigid body 2D's component, under info, we'll see a grayed out field for velocity, and we want to write some code to add upward velocity to the bird to make it fly into the air. The problem is, initially, a script can only talk to the game object's top. Top bit and the transform. Right now, this script is completely unaware of the other components, so we need to sort that out first. We need to make a special slot on this script for a rigid body 2D, so we can then talk to it and send it commands. This is called a reference. We're going to create the reference up here, between the class name and the start function. We're going to write public rigid body 2D my rigid body. So we now have a slot to store a rigid body 2D, and we have a name that we can refer to make sure we're talking about this specific rigid body 2D. And because we made it public, it means we can access this slot from outside the script. So if we save and go back to Unity, we'll see that the script component now has a field for a rigid body 2D. We can drag the component into that slot and voila, we have established a line. The unit can access this slot from outside the script. Now has a field because we made it public, it means we can access this slot from outside the script body 2D. And because we made it to make sure we're slot to store a rigid body 2D. And we have a name that we can refer to. And to give it a vector2.up, 0, 1 would be a good one. I'm going to use vector2.up, which is a built-in shorthand for 0, 1. And to give it a bit more power, I'm going to multiply that vector by a number, say 10, which should send the bird flying up in the sky. Now, so if that script and hit play in Unity, off goes our bird. Bye. That's not what we want. We want this to only happen when the player hits the spacebar. So it's time to use the most fundamental bit of programming code. Around some code, game meets is read with velocity. This time we're not talking to a right input space. This asks Unity if the spacebar has been pressed on this frame, and then we'll finish with equals true. Same as the thing on equal signs, we use 1 to make the thing on the left be the same as the thing on the right. And we use 2.
Nếu tôi không có nhăn lên, khi tôi bấm thì nó mới đi. Cái này thôi. Left. Okay. Thì nó bắt phải nhận một.
Nhận gì đấy? Nhận 10. Nếu mà camera lắp vào mình thì mình phải cho tất cả những cái gì, không phải mình di chuyển, phải là mình di chuyển. Và thôi cái code đã, cái code được người di chuyển đã, xong rồi kiểu gì sẽ code được người khác di chuyển.
Sao?
Nghe đúng. Nếu như mà không phải người nếu mà background di chuyển ấy, thì nếu mình nhấn A thì nó phải đi sang phải, đúng không? Background đấy không phải người ấy. Người đúng là nó đi sang trái, nhưng mà nếu mà mình nhấn A background thì đi sang phải. Bởi vì người đi sang trái
Đó, mình có thể attach camera vào thì mình mà, đúng không? Yeah, let's try. Này, nghe cũng rất hợp lý, nhưng mà tôi không biết trường hợp là sẽ nào.
À không. Thế thì đúng rồi, thế thì mình di chuyển cả người cả camera. Đúng rồi. Thì sẽ di chuyển cả người cả camera. Người sẽ đi bên trái và camera cũng đi bên trái luôn. Camera đi bên trái thì cảnh sẽ đi bên phải, và người và camera vẫn ở giữa camera.
Sao nó phải tập? Small xuống. Velocity thôi, linear velocity là gì nó không biết. Cũng chả biết.
Có mà. Có velocity mà. Ý là linear velocity x có mà.
Yeah, nghe nó hợp lý mà.
Yeah.
The x component of linear velocity of the vehicle body what unit per second. Không hiểu tại sao nó lại được.
Convert type to float. Phải typecast là không à? Vector 2 là gì? Vector 2
Thế là chuyển vào thanh trừ 10 gì đấy. Thế là 20.
Wait. Nhưng mà sang này là có.
And then we'll use curly brackets. These are the fence in our analogy, and put the flap code in here. So now in update, every frame the game will go to the gate and be asked, hey, has the spacebar just been pressed? If yes, the code will fire and the bird will flap. If not, it will skip the code.
Cái này wait, nó là bên tên là của bên nào nhỉ? Body 2D.
Tạo cái body là tương tác với click body bên ngoài.
Cái này
Cái tay mà tôi để bên trong, còn bây giờ tôi sẽ kéo cái body bên ngoài vào thì code của tôi để mà tương tác với cái bên ngoài.
In the curly bracket. If yes, every G has been pressed.
Thay đổi vật lý của cái rigid body bên ngoài. Có nào cái câu lệnh nó thành cái gì rồi thôi. Nhưng mà tay thì không biết nó là cái gì nữa. Velo chuẩn rồi, giá trị của mình là gì?
Float, này là float. Còn cái kia là vector 2. Vector 2. Cái nào là float angle.
Position. Đấy. Đánh nó GPT thôi.
Lại đấy con vai chứ. Bây giờ con vai thôi.
Ôi. Không vai như nào ấy nha.
Đấy, xem.
Then, and then we'll use curly brackets. These are the fence update. Yes, the code will next. Ta-da! So, save the script and go back to Unity.
Sẽ suy xong chạy Unity. Đấy, mình chỉ cần dùng notepad thôi. Nhưng mà cái thằng gì nhỉ? Visual Studio nó sẽ kiểu gợi ý cho mình ấy.
Yeah. Giờ muối.
Chạy này.
Tôi phải cân đối đâu ra tôi phải cái body tôi phải ném cái body vào. Rồi về lý thuyết thì nó lên chạy. Rồi. Tắt dần.
Thế
xuống.
Rồi
lôi mày. Đó.
Đọc
X có thay đổi không?
X. Thế là Y mà.
Nãy nó không. Đấy đi sang -1. Nó sang -1 không?
Wait. Thế thì vector 2 -1. -1 không đúng không? -1 và 0. Yeah, -1 và 0.
Di chuyển nó đến vị trí chứ không phải là.
Đúng rồi.
Yeah.
Nó là move position.
Position.
Dễ thì được khác.
Ý là linear velocity là nào? Cái x không được tại vì nó đang yêu cầu.
Tí để tao xem cái.
Tại vì cái left này cũng define ra chục x rồi mà cái x đấy cũng define phát nữa là chục x, khả năng đấy là lý do. Thử linear velocity xem. Linear nó là yeah, just give it a try. Just linear velocity. Cái x nó define một lần nó chục x rồi mà cái left cũng define theo x nên là đúng không? Ý là cái left phải define là chục x rồi, cái velocity x cũng define chục x như là yeah.
Wait. Cái này hình như đúng bởi vì nó là vector 2. Còn nếu mà
Logic nó bị collide đấy. Xếp rồi bấm vào trong này.
Không, thì đúng rồi, nó đúng rồi.
Đúng rồi mà, đúng rồi, nó chỉ đổ thôi. Đúng rồi.
Tại vì velocity mình đang đổ mà mình đã chạy.
Mình là dạng capsule nên là không cất vào. Nó chuẩn rồi. Chuẩn thôi.
Thử này này.
Tôi biết được đấy.
Cái này như nó reload được.
Rồi, trả lời đấy.
Capsule collider.
Đấy, đổ nghe thôi. Hay rồi, hợp lý rồi. Giữ là phóng đi luôn. Hợp lý. Why? Hợp lý. Cứ tự nhiên chỉnh cái position được. Yeah, nó yếu đuối rồi. Bấm reload rồi.
Nó phì luôn rồi. Thế rồi đúng không? Vậy.
Rồi nhảy vào auto save không nhỉ?
Không auto save đâu. Nhưng mình vẫn phải Ctrl F để mình save cái này á. Không sao, chắc không sao.
Thành công ấy, thành công. Vui nhá. Ôi.
Để cái collider
Ôi rồi.
có chứ. Ở đâu?
Tôi nghĩ là có rồi.
Chờ đợi đi ăn đến 4.
Được rồi, không gì. Kêu thôi. Ra được làm cái gì đâu.
Ôi giờ ta biết rồi. Nhưng mà mình nếu mà nó phải tạo rồi. Mình chỉ mở lại file đấy thôi.
Yeah, có cái lựa chọn này connect to Unity Cloud nhưng giờ tôi đã chọn gì?
Đây để đâu?
Tôi để nó trong cái này là random game. Một file đây mà. 1 chấm gần 2 GB mà. Sao lại mở cái đó? Đó đó, thứ này không có đó à? Có mọi thứ trừ cái những gì ta làm hả? Cái gì?
Tắt tiền.
Tắt cái gì? Đấy, chỉ thấy thôi, mấy cái sample tạch thôi. Đúng không?
May mắn thì cái asset nó ở trong đấy. Thế là cái asset và cái vớ vẩn.
Ok. Đi rồi. Còn này. Nó ở đây thôi.
Nó không nằm ở trong này thôi. Nhưng mà mình vào hướng hôm nay là spam Ctrl S.
Auto save chứ đúng không? Auto save ở đâu? Được auto save rồi.
Không có thế. Nó là cái này đấy.
Chia ra. Cái S là cái gì?
Chữ S là lưu.
Ý là nó lưu rồi đúng không?
Không. Chưa, nãy nó có dấu sao cái là mình chưa lưu.
Ok.
API mới của nó.
Add nào nhá.
Create 2D.
Làm gì với cái này?
2D object.
Mình làm gì nhá?
2D object. Không phải. Component đầu tiên là cái sprite.
Swap được. Còn cái rendering. Basic file đây. Bốc collide đâu.
Rồi. Mình vứt cái thằng kia vào.
Cái này mà xong. Cái này đúng không? File đây rồi đúng không? Cái bốc collide đâu đâu.
Thì mình đang nghĩ là nên remove cái box collider xong rồi lấy lại.
Ra tôi làm rồi. Bốc phải basic file đây.
Có cái đấy á? Cái body.
Cốt không nguyên đúng không? Cái body vào trong tùy mình. Cái tình hoa cho nó. Thêm cái empty. Và đây. Component. Và renderer. IO. Zoom lên. Rồi add component hủy dịch lại đây. Rồi
Đó là cái form. Không phải nhầm. Đó là cái point, cái đường thẳng. Là cái gì? Đó là cái gì nhỉ? Đây thì không phải join cái collider gì đấy. Cái X collider.
save cái rồi chạy.
Wait.
Nó lát đâu nhỉ?
Nó là
Chúng ta đã save rồi. Ôi, nó phèn vậy.
thôi, nó code rồi. Là code đấy.
Nếu code thì
Mà sao sai được nhỉ? Nó lại Y là lại chết từng code. Em không phải nào như đổi đến ít lại.
DVD xem nào. Khi nào quay là nó chết không?
Không biết được nhé.
Make,
Rất đần đấy. Nếu mà Y cái này mà chết nó đần lắm ấy. Bởi vì chẳng press gì cả. Cả lý thuyết thì nó không thể là phát được. Nhưng mà trên này thì input.ft Crash kìa. Báo
Code làm crash rồi mà.
code làm crash.
Nha.
Ý là nó update liên tục và update trong khi nó update liên tục nó phải while. Điều kiện kiểm tra nó không hề đúng, và trong cái lý thuyết của assembly thì code nó không bao giờ chạy. Vậy nha. Cái velocity mình vẫn đúng nhưng mà ý à, tới lúc để kêu
Tôi rất cẩn thận và rồi phiêu nghĩ được rồi.
mày hay nha.
Tôi bảo nó update liên tục nhưng mà chẳng có gì xảy ra.
Bây giờ làm Unity cảm giác hay hơn hồi trước làm kiểu đần vậy. Bây giờ làm nó không hay như này. Ép key đâu. Bỏ down đi. Nó vừa recommend như thế. Thôi nào. Rồi. Hỏi đi ra mới mua PC rồi đấy.
Nói gì nữa.
Ok. Tại chúng ta copy paste và key down bằng đêm. Velocity là 1. Nó rơi rồi. Đây là đơn với đuôi. Rồi mò đó.
Đây. 1. Nhưng mà còn nữa thì nó space. Ok.
Giữ space nó nhảy liên tục á. Get key down thôi, cái này get key down.
Recommend nó có ấy, nó phải get key down hay không? Rồi.
Nhìn nhảy.
Rồi.
Ok.
Trời ơi, nói gì nữa. Ôi, cái đọc của nhau.
Đâu xong.
Thì nó phải check xem nó có đang ở mặt đất không nữa.
Nếu mà mặt đất là không thì if y bằng không. If y khác không thì if y bằng không thì mới cho nhảy, không thì thôi.
Xong thì max nó lên 2 chẳng hạn.
Thôi nào, ý là mình phải exit xong mình bật lại. Nhưng mà tăng max thì tốc độ với thời lý sức là chậm đi. Không à?
À đâu, mình chưa chỉnh.
Từ nãy.
Cái tốt thì đây. To thì cho nó đã. Có lẽ là có thay đổi.
Giờ đi chậm hơn đấy.
Đúng không? Đi chậm.
Thiết là thế.
Không, cái là gia tốc thì mới ảnh hưởng liên quan tới ấy, là velo mà. Mình là velo mà, bao nhiêu mass bao nhiêu nữa thì velo. Nếu mà lực cái F của MA thì mới ra nó bị chậm lại, cái A thì mới chậm lại cái velo chứ. Kể cả là A thì nó vẫn là thành số, nặng bao nhiêu vẫn thế. Tôi cũng nghĩ là mình cũng là velo đúng không? Đúng là velo nhưng ý là tôi đang muốn cải thiện tốc độ rơi xuống hơi lâu. Không có rơi xuống nhanh hơn đâu. Cảm giác là không.
Nó phải là
Ồ,
mát thằng một
hay. Gravity scale.
scale nó nặng lên. Thế nó béo.
Rơi nhanh hơn, nhảy thấp hơn là sao vậy?
Không đúng, nhảy thấp hơn bởi vì gravity cao hơn mà. Nhưng mà 10 thì trọng lượng phải ảnh hưởng đến... À không, không.
Chắc không ảnh hưởng đến velo được.
Không, nó là cái gì nhỉ? Velo hay là acceleration nhỉ? Nó phải là nếu mà đi theo chiều y nó phải acceleration. Không phải. Ừ. Có lực.
Rồi sẽ lên.
Linear velocity. Yeah, nếu mà mass tăng thì velocity sẽ không ảnh hưởng. Hỏi duty không? How to make the character for faster. Không nha. Downforce.
CD trục Y.
Không hai nhỉ, trên này hai này.
Càng rơi càng nhanh.
Cái này càng rơi càng nhanh. Hay.
Thì cái này cao không có sẵn à? Tôi tưởng nó luôn có sẵn nhé. Khi mà mình vật lý thì nó phải có sẵn.
Yeah, vật lý và sáng tạo nó không như nhau.
Nghĩa là khi mà nó tạo ra tính năng vật lý ở trong cái game rồi thì trong cái Unity rồi thì nó phải có luôn.
Không. Yeah, người chơi có thể sáng tạo. Yeah, vật lý là vật lý kiểu cơ bản đấy. Nghĩa là xem tốc độ up, tốc độ down nó phải như nhau. Nếu mà mình muốn modify thêm mình phải code thêm. Như cái velocity, linear velocity bằng không cái code ở trên.
Đây là khi nó phải ít ground được nữa.
Không, ở trên nữa.
Yeah.
Trên nữa. Cái này.
Rồi còn rồi nhanh này hai ở đâu cũng
Không được. Đó. Vector mang body.
sang cái này chạy nhanh hơn. Rồi tính năng này coi như xong.
Yeah.
Ok rồi.
Còn này tới là còn hạ cái nhanh hơn.
Rơi nhanh.
Rơi nhanh hơn. Cái ở trên đấy, code hai phép mà. Không, trên nữa. Cái hai này.
Càng rơi càng nhanh mà rơi nhanh hơn tổng thể nghe không được.
Không phải cộng bằng nhưng mà theo lý thì nó phải càng rơi càng nhanh ít. Nhưng mà yeah, nếu mà velocity y bé hơn không nghĩa là nó đang ở trạng thái ngưỡng cực đại và hơi hạn xuống hơi rơi xuống một tí bắt đầu tính toán hay đấy multiplier falling multiplier cái này nên để là một cái constant ở ngoài cái falling multiplier
vector 2 thế nó update liên tục hay sao? Cái void update là update liên tục.
vector 2 chấm down là 0 và trừ 1, nó là vector 0 và trừ 1.
Đúng, ý là
Nhân với 0,5 thì nó là
cái này update đúng một lần, nhưng cái void update nó update liên tục. Càng rơi càng nhanh nhân với 0,5.
Thì nó là cộng bằng trừ 0,5 luôn. À đâu? Trừ 0,5.
Trừ bằng
0,5.
Thôi rồi, cộng bằng
Linear velocity đúng không? Và phải ép đỡ
rồi phần nó phải nhà tạo đi bắt ở ngoài. Ok.
cái multiplier đó là đâu? Yeah, multiplier mình có thể để 0,1 chẳng hạn.
Khiếp thật. Nói luôn hả?
Tốt. Thế luôn à?
Nó đần, nó lẽ ra nó phải có velocity từ đầu đấy, lúc nhảy lên nó bắt đầu nó phải
Lúc nhảy lên nó vẫn dần
đấy, kiểu nhảy lên xong rồi đến nó bắt đầu hơi xuống này nó bắt đầu phọt xuống.
thì đấy thì mình có thể copy paste cái code vào dãy và mình để check lên thôi, check hướng lên thì là velocity lớn hơn không thì velocity lớn hơn không thì cộng bằng 0,1.
Thì là vật lý luôn luôn tồn tại nha. Đúng ra mình phải cho nó một cái velocity, một cái accelerate xuống dưới. Cái này nghe đần lắm. Không. Không, nghĩ là sao lại cộng velocity bay lên luôn, bay luôn đấy. Ôi. Trong vật lý bình thường như nào? Quan trọng tôi chưa biết cái vật lý trong này nó là như nào để khắc chế nó. Cho kinetics này. Ủa, nó mất luôn cái
Động học à?
À, nó không rơi nữa. Chỉ có cách nào? Ui, chưa có gì cho nó rơi xuống cả. Chỉ có cách thì nó đi lên 10 ô. Không, tôi nghĩ là phải kinematics xong rồi if nó chạm đất cho nó rơi.
con trò này nhé.
Đồ mẹ cái model. Ôi,
Mình chưa biết bác làm gì.
không mát thì ra là mát thôi, bắt đầu mình tương tác cái gì với mát.
Mình đặt cái gì mask kiểu mình nghĩ là kiểu tức là nó sẽ để mình tương tác ở trong code đấy.
Nha, kiểu kiểu nghĩa là liên quan đến chỉ có Acele nó mới liên quan đến mát thôi.
Nếu mà cái này
Tương tác nhiều thứ nữa, mát thì quan trọng. Đây là Velo nó trải hồi cái mát đấy. Trừ quê gì quê quê cái gì nhỉ? No point, nhưng mà sẽ nhanh hơn, vẫn sửa cái mình muốn. Mình biết là cái này sẽ làm cái sẽ rơi từ từ hơn, nhưng nó có rewind khi nó không luôn luôn nó phải có cái không được cái không được cái là mình cập nhật cái Velo khi cái cần phải thay đổi Velo cần luôn luôn thì kéo nó xuống.
nên mình tìm thôi.
Giờ tôi nghĩ sẽ là top trong được nó kéo nó xuống. Scroll
Top là gì nhỉ? Top là lực xoắn à?
kiểu vậy. Phải có Acele, không thì nó sẽ là top.
Khả năng là top rồi, nãy là tìm ở sai này không có.
Thế là top.
Thế phải xét ở trong cái sway à? Ôi, Alpha X, Alpha Y à? Hay.
Xong rồi chia cho mát ra Acele.
Yeah. Thì chắc đây là đây đi đâu?
Bỏ điên.
F bằng 3 nó là total force. Mình sẽ có một cái base accelerate. Kiểu base accelerate là một cái constant, xong rồi mình thêm nhân với mass thì nó thành force. Và cái accelerate thì nó sẽ là một cái constant unify ở ngoài.
Đầu tiên là nó phải add force lực cũng bây giờ mình điều lúc start mình tạo ra một cái force y bằng g trừ 10 đấy.
G là 10 đúng không?
Trừ 1 thôi, nhưng mà tại sao trừ được s à?
Mình vẫn chưa biết là tự nhiên đơn vị nào.
Đơn vị
Nhưng mà
quốc
force
unit
chắc
rồi.
là Newton.
Đơn vị quốc unit rồi.
À,
Quốc unit per mass unit, quốc unit nhân với mass unit. Đó. Kiểu vậy. Có còn hàm.
force là một cái gì? Ồ.
No point mò cái này cứ phải gì thì ha.
Nó ngáo ấy, ý là cái DVD này là DVD cũ.
Cái thằng
false. Alphonse Y nó là float mà, chứ không phải vector 2 đâu. Thì nó sẽ là một cái float thôi. Thì nó sẽ là 10s, không cần new đâu. Hả? Được, tất nhiên là được chứ.
Fox model 2D chấm
Yeah, mình hover qua cái này nó sẽ có cái doc của nó. Nó nhận là một cái float và optionally là kiểu type of force.
cái Fox ở đấy, nhưng cái Fox này sách phải bị xóa khi mà mình chạm đất. Rồi em. Mình còn Fox ở đấy thắng được trọng lực. Nhưng mà nó sẽ bị xóa. Chỉ cần một cái Fox thời thôi, xong rồi xóa luôn hả? Khó nha.
Thật ra khi nào mình cần force. Cảm giác nhảy mới hơn đấy. Force gì đấy? Cảm giác là gì nhỉ? Hay là sao?
Hình như có tính chạy.
Không?
Trong code không có nha, đúng không?
Này dynamic mà từ nãy là cái gì ấy?
Nãy là dynamic mà, đúng không?
Dynamic đúng không? Thế sao lại có cái này?
Nó luôn có rồi, nãy là một, bây giờ tôi chỉnh hai nó giữ hiện ra thôi. Nãy giờ nó đều có cái đấy.
À.
Thử thay đổi mask.
Cảm giác force có ảnh hưởng đấy nha.
Là chắc không khác được.
Force, lực gì?
Push là xung là chắc là một phát rồi hết luôn.
Đúng rồi, instant force.
Vì vĩnh viễn, còn khi bấm spec thì nó cho cái xung.
Mặc định là force. Base cho mass. Mass là 1 thì force không thay đổi.
Giao info down physically. Mang tính vật lý vào này. Physically.
velocity là này, thêm lực impulse là nha. Dạ dạ. Nó có thể thử đấy. Có thể velocity what? Reset apply upward force. Oh oh upward force à. Thế thì đây là thêm kia vào tự nhiên velocity y bằng không force y cái này là 10 force là lực đi một là impulse. Anh hình như lực này hơi yếu nhưng mà có vẻ chuẩn.
Lực này là force mà, cho nên chắc chắn phải ảnh hưởng đến mass.
Yeah, nhưng mà có vẻ chuẩn.
Nhá, tăng cái đấy cũng chuẩn đấy. Không thực thay đổi mass thì một
Yeah, thay đổi mass thì phải lưu rồi chạy lại.
cái kia ông chạy lại rồi mà, chẳng qua vì không phải bấm chạy rồi. Sao nhỉ? Còn một của cái scale đấy rất là ảnh hưởng.
Không, một thì 10 nhân với 1 thì nó cũng là 1. Cái này là chỉ multiplier nó kinh hơn thôi. Đấy, cái này 2 nhảy cao hơn rồi. Ok, chắc chắn đấy. Có nghĩa là kiểu tầm khoảng giữa 1 với 1 với 2 là đẹp. Giữa 1 với 2 nếu muốn nhảy cao nữa thì để có thể 1,5, 1,75, 1,25.
Xem.
Ê, thì lại.
Thế đó. Trông buồn đấy.
Nói. Bây hỏi có ra luôn mà. Lực impulse. Chứ không phải là constant. Em sẽ có một cooldown cho.
Rồi. Ôi. Ok. Theo mình phải làm gì nhá? Left click và attack. Ui, attack là bông hóa đảnh nhá.
Bây giờ phải không spy.
Chìa khóa đâu nhỉ? Ai chìa khóa tôi ở đâu? Đây hả? 7:30 rồi. Người hấp dẫn nhỉ? Bài trí. Viewer thì không có.
Từ 8 giờ mẹ.
Đây nhà tôi chưa ai về. Sao rồi?
Now, we've done a lot of different videos on combat like shooting or strategy, but one thing that we've never done is melee fighting. So in this video, we'll have a look at how to implement some solid sword combat in Unity. You can of course adapt this to any kind of melee weapon and will the encryption. Another great function support with just a main camera, a ground environment object, a player, as well as a bandit that is currently just standing around. And if we play the game, we can see that the player movement and animation has already been set up. I did this following our videos on movement and animation, so if you don't have that working already, definitely check those out. And those of course also show how to do jumping and crouching, but I chose not to put that in here. You'll also notice that the bandit is currently just playing an idle animation. There's no logic on him yet. The sprites that I'm using here are free on the asset store. We'll of course have a link to them in the description. The only thing that here is just playing an idle and put that in here. Definitely check those. I did this follow. We can see as a bandit that is currently just standing around. And if we play the game, we can see that the player movement and animation has already been set. Up. I did this following our videos on movement and animation, so if you don't have that working already, definitely check those out. And those of course also show how to do jumping and crouching, but I chose not to put that in here. You'll also notice that the bandit is currently just playing an idle animation. There's no logic on him yet. The sprites that I'm using here are free on the asset store. We'll of course have a link to them and change the description. The only thing that I'd recommend is to say, I think that we're working with and find the sprites and change the pixels per unit to 32 since we're working with pixel art. But you can of course use any kind of art that you'd like. And I think that we are ready to start creating some player combat. So let's go to our player object, add, and let's open it up using that statement and say if input dot get key down, and the key that we want to check for
Today we are going to create a game. We have the ammo, okay? So we have a fixed amount of ammo. So we have only 20 in the beginning, 2 bullets, some of them are moving slow. So click on that, it says this in different, so what happens in the script by itself. And if you look at the explosion again, if I double click, you will be able to see that this is basically a simple keyframe animation. So we start with a small explosion and then just goes bigger, and then just cannot create the bullet, so we're going to use hit create. So the arrow that is given space. Here a bit. Okay. Any questions so far? Are you guys following? All of you will call now, and I hit OK here. I will see that because it takes the name from a linkage name. Okay. We can actually go to the library. Yeah, it's called MC Bullet. Let me select him here. Now fill color is going to be dark blue and stroke color is going to be light blue. Okay, so that looks fine. So this is our first step of using. So what do we that we want height of the screen.
So hello and welcome.
Animate CC is a crazy app. It's one of the world's most popular animation tools, and that's despite Steve Jobs personally trying to kill it, Adobe almost never updating it, and the fact it was originally designed to make websites. In the first few minutes of this class, I'm going to show you everything you need to know to start making and sharing your own animations. And then every minute of the class after that, I'll show you new tools that will make Animate CC easier to use and more powerful. I will mention quite a few keyboard shortcuts, and I'll have a list of them in the description below. I'll be covering lots of ideas today, but don't be afraid to pause and rewind sections or try out little side quest animations if a tool inspires you. So let's jump in. So I've opened Animate CC and I'm going to click on Create New. Then I'll set my resolution. So at the moment I'm going to Animate CC is a crazy app. It's one of the world's most popular animation tools, and that's despite Steve Jobs personally trying to kill it. Animate CC is a crazy app. It's one of the world's most popular animation tools, and that's despite Steve Jobs personally trying to kill it, Adobe almost never updating it, and the fact it was originally designed to make websites. In the first few minutes of this class, I'm going to show you everything you need to know to start making and sharing your own animations. And then every minute of the class after that, I'll show you new tools that will make Animate CC easier to use and more powerful. I will mention quite a few keyboard shortcuts, and I'll have a list of them in the description below. I'll be covering lots of ideas today, but don't be afraid to pause and rewind sections or try out little side quest animations if a tool inspires you. So let's jump in. So I've opened Animate CC and I'm going to click on Create New. Then I'll set my resolution. So at the moment I'm going to set it 1920 by 1080. You can change this later if you like, it's not a big deal. And then I'm going to set my frame rate to 12 frames per second. You can do any frame rate you like. Once again, 12 I find useful for 2D hand-drawn animation. I'll click Create. Now we've got our canvas in front of us. This is also sometimes called a stage. And we've got our timeline at the bottom. I'm just going to press B for the brush tool, or you can select the brush tool over in the toolbar over here. And I'm going to start drawing a little ball. I'm using pressure sensitivity because I'm using a tablet. You can turn the setting on and off on the panel over here, and you can change the stroke width over here. So if you don't have pressure setting on and off on the panel over here, and you can change the stroke width over here. So if you don't have pressure sensitivity and you're using a mouse, you might find that your brush is a bit thick. So you can use this slider to make the stroke width a little bit thinner. So we have our first frame of animation. Time to make our second frame. Each new frame in Animate CC is called a keyframe. I can make a new keyframe by going to Insert, Timeline, Blank Keyframe. But as you can imagine, doing that over and over again is going to get pretty tiresome. And what you can do instead is press F7 on your keyboard, and you can see it down here. It's got a new blank keyframe. It's a different color. And now I can't see my old keyframe, so what I need to do is click on this little button here for onion skinning, and that will show me the previous frames and the future frames while I'm animating. So I'll quickly trace this previous drawing, then I'll select. Today I'm sharing 4 animation exercises and not one. Animate CC is a crazy app. You can do any frame. Now we've got our canvas in front of us. This is also sometimes called a stage, and we've got our timeline at the bottom. I'm just going to press B for the brush tool, or you can select the brush tool over in the toolbar over here, and I'm going to start drawing a little ball. I'm using pressure sensitivity, frame of doing that over and over keyframe. It's a different color. And now I can't see my old keyframe, so what I need to do is click on this little button here for onion skinning, and that select it by pressing V or by using this little selection tool over in the toolbar. I'll click on the line work, and then drag it around. You can actually use the arrow buttons if you want to. I'll click on the line work, pressing V, or by quickly trace this previous drawing. Then I'll select it by pressing and move it around. So that's my second keyframe done. Now I'll just press F7 again to make a new keyframe, and I'll just animate away, just frame by frame, figure out nice little bits of spacing as I go. If I want the ball to move slowly, I make the images close together, and if I want it to move quickly, I make them a little bit further apart. At this point, you might be wanting to zoom in and out, and you can do that simply by selecting the little magnifying glass tool on the side, or you can press Z to zoom in and Alt-Z to zoom out, and just click where you want to go. And then if you want to move around the canvas, you can hold down spacebar. This will give you the hand tool, and then you can click and drag the canvas around like it's a piece of paper. I want this animation to loop, but I'm running into an issue now where I can't see where the first frame was in my onion skinning. So all I need to do is drag this onion skin slider a little bit further back to the start of the timeline so I can see, that first frame of animation that I want to loop to. Now I'll just quickly turn off onion skinning, and if I want to play things, I can click on this little play button at the top of the timeline or press enter. And what you'll notice straight away is it's not looping. So what I need to do is press this little loop button on the timeline, but then it's not looping the whole timeline just yet. So we need to drag this little slider at the top of the timeline, which is the loop range, all the way back to the start of the timeline. Now when I press enter, we've got a nice little loop. I've kept this really rough, but you can keep it as clean as you want. And also I've let the size change a little bit over time, so it feels like it's moving through space a bit. So now we have our line work. I want to fill in this line work with a color. That's really easy. We just select this paint bucket tool or press K for the shortcut. Now I'll choose our color picker. I can choose one of the existing swatches, or I can go up to the little swatch picker here and choose one of our custom colors. I'm going to choose a yellow color, and I'll just click in the middle of our circle. At this point, you might find that your fill tool doesn't do anything, and that could be because you haven't closed all the gaps in your drawing. The easiest way to fix this is to go over to the circle. I'm going to choose a yellow color, and I'll just click in the middle of our circle. At this point, you might find that your fill tool doesn't do anything, and that could be because you haven't closed all the gaps in your drawing. The easiest way to fix this is to go over to the tool menu over here and click on Close Gaps. I often use Close Large Gaps. And of course, the other way to do this is just to use your brush tool to fill in any of those little gaps that are left in your drawing. Now I'll just step through each frame and fill it in. You can drag through the timeline to do this, or you can use a faster method, which is stepping through the keyframes using the comma and the full stop button. Okay, now we're finished. I can press enter and watch back our animation. It's looking kind of cool at the moment, but I think we can add some extra ideas. So what I'm going to do is create a new layer. I'm going to create a new layer above this existing layer. I'll quickly change my brush color, and then I'll go down to our layer panel here and click the plus button. This will create a new layer on top. And I'll also click the lock button for layer 1. And this will mean that I can't accidentally edit the animation I've already done. Now I'll draw in some leaves and fill them in. And I want this to stay still throughout the whole animation. And you can see in the timeline that there's no little breaks in this keyframe. And that means it's going to hold for the entire time. If you ever want to extend how long a keyframe's holding for, you can simply press F5, which will give you a little bit of space in the keyframe. And then if you want to move them around, you can just click on them and click and drag to where you want them to go. And that will just retime where they go and put them on different layers as well. If you want to delete some of these keyframes, you can shift select them and then press Shift F5. And that will just delete your keyframes or any held frames that you've got selected. So the last part of this animation I want to create now is a little stem for the flower. So I'll make a new layer and then animate straight ahead a little stem. So every new frame I want to create, I just press F7 again. And that'll create an empty frame on the timeline where I'm at. So I'll just use my onion skin and blast through this animation straight ahead to loop back to at the start. Now we have a nice little looping animation of a flower, and I want to export it to share it with people. So there's two main ways to do that. We've got export to SWF, which is a special flash file, or export a video. Exporting a SWF keeps everything in vector format, but it's really hard to share on the internet. While exporting video will be a lot easier to share on Instagram and things like that, you won't keep any of that vector information. When I say vector information, I mean that unlike normal video software, Animate CC uses mathematical lines to create its images. And that means you can scale it up to any size you like without it getting pixely. I'm going to start by exporting to Swift, and the best way to do that is by pressing Control Enter or Command Enter if you're on a Mac. This will open up a new window, and you'll have the name of the file at the top, untitled.swift. It'll save it in the folder where your animation file is saved. But because our file isn't saved anywhere, now seems like a good time to actually save our file somewhere smart. So I'll go to File, Save As, or Command S. And I'll just save that somewhere with a name, like flower and then a version number. And now you can see this file on your computer. But as I said, Swifts are kind of a funny file format. They're good for using in After Effects or just previewing your animation. Unfortunately, they're harder to share on video platforms. So let's make a video file instead of a Swift file. I'll go File, Export, Export Video and Media. This will bring up a dialog box, which will let us export a H.264 and send it straight to Media Encoder. Media Encoder is actually a separate app from Animate CC. So if you haven't installed it yet, you can install it from your Creative Cloud suite here. Okay, back to this dialog box. H.264 is just the encoding format, and it's a pretty common format for internet videos. I'm using all the default settings that I've been offered, but if you want to pause it and check them against your settings, you should do that. And
Đây, đây. Ôi, ôi, ôi. Bạn căn nhận đếm được bao nhiêu cái số, đếm được, đếm được, đếm được, đếm được, đếm được, căn nhận đếm được bao nhiêu cái số, đếm được. Bộ đồ viết. Hey. Trời ơi. Trời ơi, nói gì nữa. Ai, ôi giời ơi, nó không ơi. Ôi, trời ơi. Ok, quay trở lại. Hay đây em ơi. Nghe bài hiểu thứ hai này. Đấy.
And unfortunately, Media Encoder is notoriously glitchy, and I had a hard time doing this the first time, so I actually had to make sure Media Encoder was open, and once it's open, you can go back to Animate CC and click on the export button. And once you've done that, it'll run it straight through Media Encoder, and once again, it will save it automatically in the file directory where your main file is stored. So at this point, we're only 8 minutes in, and you have a movie file that you can share with your friends, and all the skills you need to start making your own animations. Over the next 15 minutes, I'm going to show you how to take this animation a little bit further, using some of the more powerful tools within Animate CC. So let's jump back in, and I'll show you what I'm going to do. A big part of Animate CC we haven't touched on yet is the idea of symbols. So rather than trying to explain what a symbol is, let me just show you.
đến được, không đến được.
So when it comes time to start adding animation to your game, it's a really a database that animation. Let's then double click this folder and let's also rename this animation here folder.
About a year into the development of Portal, playtesters kept giving Valve very similar feedback. Something along the lines of, "That was a great tutorial." The Latch Row. It's the hot new indie darling. It shifted 1 million copies in a month. Points. But on top of that, you can do all sorts of wily tricks to boost your score. Special card. Hi, I'm Mark Brown, and this is not a usual episode of Game Maker's Toolkit. It's been a while since my last video on this channel. Sorry about that. I've been taking some time off to, well, get married, have a holiday, play some video games, they're pretty fun, and most importantly, well, not more important than my marriage, but second most importantly, I've been thinking about what I want to do next on this channel. And so, without beating around the bush, this is what I've decided. I'm starting a new series where I make a video game. A very small video game, a very bad video game, but a video game. And I want to Last time on developing, I picked my game engine, Unity, and I started to learn how
And here are 4 different images. If we just try and select one of them, we can see a printer for this, and then in Windows, so we'll go under Windows to draw our character. move and jump around as well as crouch beneath platforms. But of course currently we have no animations in here. To change this, let's start by setting up some animation clips. To do this, we'll go to our scene view and select our player. We'll then open up our animation window. So we'll go under Window, Animation, and select Animation. And as you can see, it tells us that to begin, we'll go under Window, Animation, and select Player. We'll then start by setting up our animation window. So we'll go under Window, Animation, and select Animation. And as you can see, it tells us that to begin animating the player, we need to select Animation. And as you can see, it tells us that to begin animating the player, we need to create both an animator and an animation clip. We'll talk about the difference between the two in a sec. For now, let's just hit create. And now we can choose where we want to save our animation. Let's right click and create a separate folder for this. And let's call it animation. Let's then double click this folder. And let's also rename this animation file to something like player. And then underscore the animation that we want to work on. This could be run, jump, or die. In our case, let's start with an idle animation. In other words, the animation that the player plays when he isn't really doing anything. We can then press save. So now we have this empty timeline here where we can drag in our animation sprites. Of course, the great thing about our character here is that he already comes with a bunch of images that we can use. So let's go under Sunnyland. And of course, if you want to download any of this, I will have a link for that in the description. We then go under Artwork, Sprites, and under the player, we can see that the sprites are split up into animation folders. So let's start by going under the idle folder. And here are 4 different images. If we just try and select one of them, we can see a preview in the bottom right here. Of course, it's pretty tiny, but if I go ahead and move through the images, we can see that they are indeed animating our character. So let's try and select all 4 sprites, and let's simply click and drag them into our animation window. And right away, we can see that 4 keyframes has been added. We can also see that if I hit play, the animation plays ridiculously fast. The reason for this is that we need to change the amount of images that are displayed each second. Currently our samples are set to 60. A pretty standard value to use here is something like 12. We can see if we now play through, the animation looks much better. And we can even scrub through it using this timeline marker. And if we wanted to say move around a few images, we can of course do that by simply clicking and dragging, or just press delete in order to remove one. But I'm just going to leave my animation as is. And let's go ahead and set up a few other ones while we're at it. So let's go to where it says player idle here, and let's hit create new clip. Again, we want to make sure we do this inside the animation folder. And this time, let's create one called player_run. Now let's go under our run folder. Let's select all of our sprites and drag them in. Again, we want to decrease our samples to 12. And if we now hit play, we can see our character is running. Let's quickly do this for the crouch animation as well. So player_crouch. We'll go under the crouch folder, select both of them and drag them in. Again, we'll set the samples to 12. Again, the animation plays fine. And finally, let's add our jump animation. Player_jump. We'll go into the jump folder, select both sprites, drag them in, change these samples to 12. And if we try and play this one, we'll notice that it looks kind of weird. The reason is that our jump animation is made up of only 2 keyframes. One for when we are going upwards and one for when we are falling back down. Now we could of course go in and create these as 2 different animations. However, I think that's just overcomplicating things. Instead, I'm just going to go in and change the samples to a much lower value like 2. I think this is going to change our sprite around the time when we're at the peak of our jump, but we'll see that later. So now we've set up all 4 animation clips. And if we go into the animation folder, we can see all of them here. Player idle, player crouch, run, and jump. And we can also see another file in here, simply called player, which has a different icon. This is what we call the animator controller. The animator controller is called a controller because it controls what animations to play. If we double click this, it's going to open up in our animator window. So here we notice that one of our windows is called animation. This is where we create our actual animations. And another one is called the animator because this is where we choose what animations we want to play. And in here we can also see that it's already added our 4 animation clips. We can now drag these around and arrange them in any way that we would like. And if for some reason one of them isn't in here for you, you can always take an animation clip from the project and simply drag it in. And you can of course also select and remove them. You'll notice here that currently the player idle is marked as orange, and it's connected with this arrow going from the green entry state. The reason for this is that the idle animation is currently our default animation. In other words, it's what will begin playing right when we start our game. So if we were to now hit play, we can see indeed our player starts playing the idle animation right away. And even though we move around and jump and try and crouch, it's just going to keep playing idle. In fact, if we select our player and go under the animator, we can see the animation looping right here. So let's stop playing, and we can now start to create transitions from the idle animation to the other clips. By the way, if you want to set another animation as the change it. So and underneath, we now get the position. We can change when and how we want it to occur. So the first thing that we need here is to add a condition, because we don't want our transition to just play right away. We only want it to play in the case that we're actually moving. But currently our animator has no idea whether our character is assigned to reproduce 0 transition. And you can say that we only want to transit the plus sign to create a new condition on our transition. And you can say that we only want to transition to a run animation if our speed is greater than, and it will just input some small number like 0.01. In other words, if we start moving, well then we want to transition to a run animation. We also want to go in here and make sure that this transition is immediate. In other words, we don't want something called exit time, where we wait for the animation to stop playing before we start playing a new one. No, we simply want to transition as soon as we start moving. So I'm simply going to disable that. Let's also go under settings, and here we can choose the duration of our transition. This is not something that you often use when creating 2D games, but it's used all the time to blend between animations in 3D games. But for us, again, we want this to be completely immediate, so we'll go in and set the transition duration to 0. Of course, we also want to be able to transition back from our run animation. Currently, we will only be able to go from our idle to run, and then even though we stop moving, it will still play our run animation. So we'll go in here and right click and make a new transition. This one is going to go to idle. Let's select our transition and add a new condition. This time we only want to transition if the speed is less than, and then we'll again add a tiny number here, so 0.01. Again, we don't want any exit time, and under settings, we'll set the transition duration to 0. And now our animator should actually work with these two animations. In fact, if we take our animator and dog it to the right here, and then try to hit play, we can see that by default it plays the idle animation. But if I then go and change the speed, say set it to 1, our character starts running. And as soon as I set it back to 0, he goes right back to idling. So now all we need to do now is select options. One is select our animate player need to do controller. So to do that, we can see opponent. And so if animate want to set, remember if our parameter is speed, and notice that this has a capital S. So inside of our script, we can then write speed with a capital S like this, and then comma, and then we can give it the value that we want. In our case, that this has a capital S. So inside of our script, we can then write and notice that this has a capital S. So inside of our script, we can then write speed with a capital S like this, and then comma, and then we can give it the value that we want. In our case, we wanted to give it our current horizontal speed of our character, which is this horizontal move variable right here. So we'll simply write horizontal move and close it off with a semicolon. But there is a tiny mistake in here, and that is that our horizontal movement will be positive whenever we're going to the right, and it will actually be negative whenever we're moving to the left. And we want our speed variable to always be positive. So to change that, we can go in and use a handy little function called mathf.abs for absolute. So this is going to take the value and make sure that it's always positive. So if we now save this and go into Unity and hit play, we can see that as soon as we start moving, our character is going to play the run animation. And as soon as we stop, he goes right back to idling. Awesome. Now we want to be able to jump no matter what animation is currently playing. So whether we are idling or running, we always want to be able to jump off the ground. And so we could go in here and create a transition from each single clip to our jump animation. But as we add more clips, that would quickly become very tedious. So instead we can use this any state right here. And this basically allows us to create transitions from, well, any state. So no matter if we're idling or running, we can transition to our jump animation using this node here. So I'm just going to take this and drag it down and drag the entry up here to get it out of the way. And let's take our jump animation and drag it over here. Now we can transition from any state to jump. And of course, we still need to go in here and specify a condition. Otherwise, we're just going to be jumping all the time. And for this condition, we need a new parameter. So let's hit the plus sign. And this time we want it to be of type bool. Are we jumping or not? We'll call this is jumping. And we'll just set it to false by default. And then under the condition here, we can hit the plus sign. This time we don't want to check for speed. Instead, we want to check if is jumping is true. And again, if it is, we don't want any exit time. And we also want to set the transition duration to 0. Of course, we also want to be able to transition back from jumping. So let's go ahead and create a transition to the player idle here. And we only want this to play if we are currently not jumping. So is jumping is false. And our current speed is currently less than 0.01. And so this is really cool. We can add as many conditions to these transitions as we want. Let's also add one to play run. So we'll make another transition here. And this one we want to play in the case that, again, we are not jumping. So is jumping is false. And the speed is currently greater than 0.01. Again, we want to make sure to go through both these transitions and set has exit time to false and the transition duration to 0, and the same for the other one. And now our animator should be set up. Of course, we still need to make sure to control our is jumping parameter through our script. And if we go into our movement, go in here, I'm jumping, and here we want to set it to true. However, we actually don't have a way of knowing when we want to stop jumping, because all we're doing here is really giving our player controller input. There's no place in our code where we have anything about actually landing again. To get around this, I've gone ahead and added a bit of extra code to our character controller. If we select our player and open up the character controller, we can see that there's a section here called events. And in here, there's an on-land event. Events basically allows us to trigger certain functionality when something occurs. In this case, this event will be triggered whenever our character lands on the ground. And so we can use this to tell our player movement when to stop jumping. To do that, we need to go in and create a separate function for this. We'll create a void. We'll call it something like on landing. We'll open and close some parentheses and the same with some curly brackets. And in here, all we want to do is tell our animator to stop jumping. So we'll go animator.setBool is jumping.
How I might use it in this animation. So let's say I want to put a face on this flower, but I don't want to redraw it for every single frame. I've created a new layer to put the face on, and now I'm drawing it in on that layer. Of course, I could redraw this face every single time or copy and paste it, but a more flexible way would be to create a symbol of the face. So I'll press V and select all the elements in the face, and then I'll head up to modify and then convert to symbol. And then I'll change my symbol type to graphic, and I'll rename this flower face. And now I'll click OK. And when I select the face now, it has a blue box surrounding it. And that's telling me that the face is now an object. And the object in this case is the flower face symbol that we've just created. So it's going to treat it as a single entity. And now I have my face, I can just go through my animation and move it on top of the flower exactly where I want it for each frame. So rather than creating an empty keyframe for every single frame, I'm actually going to create a new keyframe based on the previous one. So rather than pressing F7, we're going to press F6. And this will create just a duplicate of the previous keyframe that we can edit. So you can watch me here, I'm just creating a new keyframe, and then pressing F6, dragging the face to fit on the flower. and then pressing F6 again, and then doing the same over and over again until I'm through all of my animation. And if I play it back, I think that's looking pretty cool. But what's extra cool is now we can start playing with the power of symbols. So let's just say I wasn't happy with this face. I could double click on it, and now we're inside the symbol. I can tell I'm inside the symbol because everything else in the document is a little bit grayed out. And we can see a little flow chart up here that says scene and then flower face. So the fact that flower face is here means that we're inside the flower face symbol. Now I'm going to redraw this face. And what's going to happen is every time we've used that symbol, it's going to update with this new face. So once I'm happy with this new face that I've drawn, I'll double click on the background again, and that will take us out of editing the symbol. So now we can see our old timeline here. And if I press play, you can see that all of the frames have been updated with this new sad face. I actually kind of liked the happy face more, so I'm going to re-edit the symbol and throw that happy face back in. Then I'll just double click on the background again, then I'm back in my main timeline. So I feel like I've made a bit of a mistake here. I've made my animation quite small in the frame. The composition isn't that nice, it's not centered. I want to move it around. What I could do is unlock all of these layers and then drag select over all of my drawing, then press Q for transform and try to transform the whole thing. The disadvantage of that is that when we go to the next frame, we're going to have to transform it again. And that's going to be really hard to do consistently throughout the animation. But luckily, Animate CC has a solution for this. It's called Edit Multiple Frames. So if I click on this icon here, and then drag out this little header here, it shows me all of the frames of my animation that I've selected. Now I can select all of the images that I can see, press Q to enter transform mode, and then hold Shift to uniformly transform all of my animation. Now I can move it around, and I can turn off Edit Multiple Frames, and we can see our animation has all been edited all at once. Another solution to this problem would be to combine all of this animation and all of these layers into a single symbol. So let's try that out now. I'll select my top layer, and then Shift select, and then select my bottom layer. Then I'll right click and say Convert Layers to Symbols. I'll rename the symbol to flower, and I'll make sure the type is set on graphic, like it was before. Now we can see all of our layers have disappeared, and we've only got one layer called flower. And we've got a single symbol sitting on our canvas. Now I can press Q and translate and rotate and deform this all at once. And I can also press Ctrl D to duplicate it, and I can start editing these all separately. I'll just put this one here and duplicate again, and put this one over here. And now we've got 3 copies of the same symbol, all playing at once. And just like before, if I double click on this symbol, I can start editing it, and we'll update all of the other symbols. So I'll change the fill color of these leaves to purple, and then double click on the stage, and you can see all of the flowers have purple leaves now. Something that I've noticed with this scene though is that all of these flowers are perfectly in sync with each other, which feels a little bit unnatural. So what I want to do is start offsetting these flowers. And that's really easy to do. If we click on the symbol and then head over to this Objects Properties area here, we can use the frame picker to change the first frame of the animation. So rather than starting from frame 1, it will start from frame 3, and then I'll go over to this other one and start it from frame 6. There are a few more options here. We could choose not to loop the animation, or we could reverse the loop of the animation, but I'm going to keep it just looping animation as it is right now. And if you're wondering what I mean by starting from frame 6, you can just simply click on the symbol, and then you can see the timeline within the symbol. And so when I say frame 3, it's saying frame 3 from this timeline within the symbol. Okay, so we've got our flower guys that are bouncing around here. But as you've probably noticed, I've used a really rough line to draw these guys. And that's because I'm using a brush tool and I'm drawing pretty loosely. But what if I wanted to have a more controlled vector look to my animation? How would I do that? I'll double click on my symbol, go into my animation. I'll find a layer that I want to clean up and press the lock button. Now I'll create a new layer on top, and this will be our cleanup layer. And because things might get a bit confusing, I'll rename the layers by double clicking on the name and then typing in a name. So I'll name the bottom one leaf and the top one leaf_cleanup or CU. Now I'll right click on the rough layer and go to properties, and I'll select 50% opacity, which will lower the opacity of the entire layer, making it a little bit see-through and a little bit easy to draw over the top of. So far, the only drawing tool I've showed you is the brush tool, but there are a couple of other ones. So this time I'll use the line tool rather than the brush tool, and this creates a vector line. So I'll quickly change the color to black, and I'll click and hold at the start and end of the leaf here. As you can see, it's created a really thin line, which is probably too thin. So I'll press Ctrl Z and I'll change the stroke width in this property bar here. Now I'll click and drag along the entire length of the leaf, and that's created a nice straight line. And obviously that's not what we want. We want a curved line. So I'll press V, which is our selection tool, hover over the line, and then click and drag, which will bend the line into a nice curve. If you've ever used a vector program before, you might be more used to using a pen tool. And Animate CC has a pen tool, and I use it a fair bit. It works like this. It creates Bezier handles, but I think that it's a little bit less intuitive than just using a line tool. But, you know, feel free to experiment with what works best for you. I'm just going to use a line tool to finish off the rest of the lines in this leaf. Now, if you've been watching closely, you might have noticed I've made a very slight mistake here. The stem color and the leaf color lines are different colors. One's a dark gray and one's a black. So I'm going to update my lines around the leaf. I can't use a bucket fill to do that. I need to change the stroke color. I'll start by selecting the lines, and the easiest way to do this is actually to double click on the line, and that will select all of the lines that are connected together. Then I'll hold Shift and select any lines that I've missed. And then I'll go over to the properties and change the stroke color in the color and style option. When I click on this little box, it automatically goes to an eyedropper tool, which then means I can hover over our stem color, click on it, and it will change the color to that stem color. You can also change the stroke width and all that sort of stuff in this option too without having to redraw them, which is a super powerful tool. So if I press Ctrl Enter, we'll preview this with a Swift. And if you're watching really closely, you'll notice I've made another really small mistake. I've left on the rough layer below the cleanup layer. A weird quirk of Animate CC is that even if you turn off the visibility of a layer, it will still show up in the render. So what you also need to do is turn it into a guide layer. So we can do that by right-clicking on the layer and clicking on guide. Now if I preview the animation again, you can see that the rough layer is no longer visible, which is exactly what we want. Okay, so we've learned loads and loads, but I wouldn't feel good about leaving this lesson unless I showed you one last thing, and that's using what's called a motion tween. I don't use a lot of motion tweening in my own work, but it is a really powerful technique, so let me show you how we might use it. I'll start by drawing in an extra element. When we get a new layer, we put our sun at the top. Let's put a little face on him, and then fill in the sun with some orange. Then I'll press V and select all of the elements of the sun, right-click on him, and say Convert to Symbol. I'll call the symbol Sun. I'll right-click on the layer with the sun in it and say Create Motion Tween. Now we know that's worked because the layer's gone yellow, which means there's a motion tween on it. And if we go to the end of the layer and drag the sun where we want it to go, just like magic, the sun moves itself across the screen. We don't need to keep animating every single frame ourselves. Looking at the animation though, I think that the sun moving across the screen is a little bit fast. So what we need to do is add more time to our animation. So we need to add some frames to all of our layers. So I'll click an empty frame at the top, hold Shift, and then click an empty frame at the bottom, and that will select frames in the middle of all of our layers. And then I'll simply press F5 a bunch of times until I've extended this timeline out. So I've extended it to 48 frames. Now when I play it back, you can see that the sun animation is much slower. But it feels a bit funny moving in a straight line like this. So let's spice it up a little bit. I'll go to the first frame, press Q for our transform tool. I'll translate it down and also scale it down a little bit. Then I'll go to the last frame and do the same thing. And then I'll go to the middle of the timeline, press V, and hover over this green line. And that will give us a little indicator that we've got a curve tool. So I'll just drag this curve tool up so that we make a nice arc in the motion. And I'll scale it up in the middle as well. Now when I play it back, it has a nice arc to the motion and it changes scale as it goes. I want to add one more detail to this animation. I want to make the face look like it's looking at the flowers as it's going over the top. To do that, I'm going to animate the face within the symbol, using the exact same technique I've just used to animate the whole sun. So I'll double click on the sun, and that will give us a look inside the symbol. And then you can see there's only one frame of animation here. So we need to extend the timeline out, and usually I try to make the timeline the same length as our main animation. So I'm going to make it 48 frames. Last time I extended the timeline by pressing F5 lots of times. This time I'll just go to frame 48, press F5 once, and that will extend an empty keyframe all the way to frame 48 for me. Now I'm just going to transfer the face onto a new layer by clicking on it and saying Control X. And that will cut it out. And then I'll fill in these gaps with the bucket fill tool. I'll create a new layer, and now I'll select my new layer and press Ctrl Shift V. If I press Ctrl V, it'll put the pasted object into the middle of the layer. In reality, I want it to be pasted where it was before. So Ctrl Shift V will paste it where we want it. And now with the face selected, I'll convert it to a symbol. I'll call it little face. And then I will create a motion tween again. So this time I'll start on this side of the head and then move it to the other side of the head. This will be that counter rotation, which will make it look like the whole face is turning. You may have noticed I put the keyframe in the middle of the timeline then, and really I wanted it at the end of the timeline. So I've just clicked on the keyframe and just dragged it to the end of the timeline. Now if I play things back, you can see that the face looks as though it's turning as it's going over the top of the flowers. And there you have it, an absolute speed run on how to use Animate CC to make animation. I've compressed about a month's worth of education into about 20 minutes here, so don't be afraid to watch parts of this back again and check out the other videos on the channel.
Phải đến đây. Hoài mà.
platforms. But of course, currently we can choose where we want to save our animation. Let's animation and select animation. And as you can see, it tells us that to begin the animation that the player plays. Click and create a separate folder for this, and let's call it animation. Let's then double click this folder, and let's also rename this animation file to something like player, and then underscore the animation that we want to work. On. This could be the thing about our character here is that he already copies our if we drag them into our animation window. And right away we can see that 4 keyframes has been added. We can also see that if I hit play, the animation plays ridiculous. We can see that they are indeed animating our character. So let's try and select all 4 sprites, and let's simply click and drag them into our animation window. And right away we can see that 4 keyframes has been added. We can also see that if I hit play, the animation plays ridiculously fast. The reason for this is that we need to change the amount of images that are displayed each second. Currently our samples are set to 60. A pretty standard value to use here is something like 12. We can see if we now play through, the animation looks much animation folder. And this time, let's create one. Let's go ahead and set up a few other ones while we're at it. So let's go to where it says player idle here. And let's hit create new. Clip. Again, we want to make sure we do this in. Let's go ahead and we want to make sure we do this inside the animation folder. And this time, let's create one called player. Between the two in a sec. For now, let's just hit create. And now we can choose where we want to save our animation. That's right.
Nhá, đã. Đây căn nhà này. Đếm được. Con số đếm được. Cà tre hả? Rồi, 1 tiếng.
Right click and create a Let's right click and click this folder, and let's also rename this and work on. This could animate. Now, the great thing about under and go under that if I hit play. To 12, and if we try and play only 2 keyframes, one for when we go 2 different to a much jump, but we'll see that later. We can see all of them here. Player out, sim controller, A. One of all the arrows is called click this, it's going to open up in our animator window. window. And in here, we arrange them in that it's already added off. We choose what animations we want to play. And in here, we can also see that it's already added our 4 animation clips. We can now drag these around and arrange them in any way that we would like. And if for some reason one of them isn't in here for you, you can always move them. Connected with this arrow going from the green entry state. The reason for this is that when we start our game. And even to now hit play, we can see indeed our player in playing right when we start our game. So if we were to now hit play, we can see indeed our player starts playing the idle animation right away. And even though we move around and jump and try and crouch, it's just going to keep playing idle. In fact, if we select our player and go under the animator, we can see the animation looping right here. So let's stop playing, and we can now start to create transitions from the idle animation to the other clips. By the way, if you want to set another animation as the default, we can always right click and hit set as their default state. And that's simply going to change it. So whenever we start running, we of course want to change from the idle animation to our run animation. And we do this using what is called a transition. So if we take our player run here and just place it underneath our idle animation, we then right click on our idle and hit make transition. And we now get this arrow. Arrow that we can drag out to the other. Other animation clips. If we then click player run, we've created a transition from our idle to our run to occur. So the first thing that we need here is to add a condition, because we don't want the move to layer create a new parameter. We're going to create a float, and this float is going to represent our player's speed. So we'll call it this has a capital and use a handy little function. And go into Unity, we can see that we have this empty animator field, and this is where we can drag in our animator component. So now every time we write animator in our script, we can access this component right here. And made a component to animation. If you haven't watched the video where we set up player movement, we're basically using two scripts. One is the character controller that takes care of all the physics that go in, tell the player when to move and at what speed. So let's go ahead and open up this player movement script. And the first thing that we want is to be able to access our animator. Luckily, if we have a look in Unity, we can see that when we started creating animations for our player, Unity actually added an animated component to our player. And we don't need to do any adjustments in here. We can just see that the component is actually referencing the controller. And so that's why whenever we make a change to our animator controller, it applies to our player. So now we just need to be able to control our animator through our player movement screen right here. And so if we every time we write animator in our script, we can access this component right here. And so if we go into the update function where we get our, we can access this component right here and write animator dot set float, and then we give it the name of the float that we want to set. Remember, this is the name of our parameter. So inside of our animator, we can see that the name of our parameter is speed. And notice that this has like this, and then comma, and then we can give it the value that we want. In our case, we wanted to give it our current horizontal speed of our character, which is this horizontal move variable right here. So we'll simply write horizontal move and close it off with a semicolon. But then to change, so if we now save this and go in, so this is going bool this time because it's a an output for to false and the transition duration to to 0. for whenever we're moving. go to our character. Variables, but we can actually make functions public as well. If we now save this and go into our animator, exit time, remove it and set the duration here. Sometimes getting it here and over and play the game is jump. Inside of our variable right here. So we'll simply write horizontal move